All right, so here's the Python Dynamo coding for visual scripts. I'll be leading the class, Tadeh Hakopian. Along the way, if you are not asking a question or whatever, just keep yourself muted in case there's a lot of noise going on. Real quick, we'll take a class composition. In the meantime, if you haven't done so already, get the Revit and Dynamo booted up in Revit 2020 and Dynamo 2.3, I think is what comes in 2020. I posted that link. I'll post it again. File link in Amazon Drive, so that you guys can get that stuff. They're not big files. They're just vetted, so I know they work. Hopefully, there's no shenanigans with anybody's computers for it working either. So it all just falls into place. So these are the files, and I'll show you which ones that open. But you can start with that. There should be just one Revit model there, so you can open that. So I would like to take a temperature of the class. I'm assuming everybody here knows Dynamo, at least a little bit of Python coding. Is there anybody here who's just completely like new to the thing? I mean, I don't care if you are new to it, still good exposure. Is anybody here like relatively new to Dynamo, relatively new to Python, or you can either type away in the chat or talk. Right now it's still good time to talk. Great, okay, cool. So, and I'll mention that you don't have to be a pro at Python. I think I put in the class agenda that as long as you can do a for loop, you should be okay. You don't have to be like a whiz or anything. So the idea was that people would, get used to an environment in Dynamo here. So, as Kobe said, he's relatively new to Dynamo, but he's done Grasshopper. And Grasshopper is kind of like semantics of how you manage stuff in Grasshopper is pretty similar. It's a different interface, of course, but it's pretty similar. So it's not hard. So if you know Python, the logic shouldn't be too crazy. I'm not going to get into the weeds of like how to use Dynamo specifically for Revit, all the parameters and all that. We'll talk a little bit about them, but this is a class that basically glues together what you would do with Python, what you would do with Dynamo. So to kind of help you guys get prepared. So this is a little bit about me. I like to show my face a lot. And Norman, we're recording right this minute. Is it all streamed?
Yep, we've been recording for a while.
Good. Yeah, like I mentioned before, I'm Tadeh Hakopian. I've been in the AEC industry working with BIM, VDC, and different aspects of coding for 10 years. And I've been pretty focused over the years on that subject, and I work with this team in LA called HMC Digital Practice. We're a California-based architecture design firm, and we've been focusing on ways to do data analytics and process automation. So it's kind of in our wheelhouse to provide training and resources to the company and staff. And we tried this year, of course, everybody was supposed to be in person for all these events. We were supposed to have a little more networking going on. That was our goal as a company, as a group. So watch out for us if you see us in Grasshopper mode or Dynamo mode down the road. Learning objectives, we're going to learn about the Python node, how to configure it, learn how to debug your Python script when errors appear, which it honestly could be an entire 3-hour class on its own. So if you ever get into this thinking like you're going to learn it once here, it's not. You're just going to learn what it looks like and kind of how to deal with it. Learn how to execute Python with statements and conditions, and create a few Python scripts yourself. And these are going to be very basic ones. Otherwise, we'll never get anything done, but you'll be able to at least modify them. Okay. So description of this class. You already know some Dynamo. You open the software at least once or twice, and you want to learn how to take control of the editing with Python. And we'll introduce you how Python works in Dynamo and how to use it on projects and basic concepts of how to use Python in Dynamo. This is not an introductory course for either Python or Dynamo. You're supposed to learn enough of it to at least kind of follow along. We all have different levels and skills and abilities. So depending on the person, it might be, depending on the person, I'm assuming everybody has an elementary level. So some people might be way ahead of whatever I'm instructing today. So hopefully this becomes a good reinforcement of your knowledge. And some people might be very new. This could be something you're trying to catch up to, which is fine. I think as long as we all kind of have a similar baseline of knowledge here, afterwards we'll be in good shape. And what you'll get out of learning is, let's get this one. So the instruction will be, we'll show different ways you can use that Python and Dynamo. That'll be one thing. So I'll be going through a series of scripts. So I'll show you like the very, very, very basic fundamental scripts in Python and Dynamo. And some of these will work on together. I'll ask you guys to open up your own session to work on it, so that we can type together, just so you can get the muscle memory. Otherwise, we'll just be talking for 3 hours. So, and I'll show you which ones we want to. And I should mention, I think this is true for most softwares. There's different levels, and I'll show you those levels in a minute. But the API will be one we'll get to at the towards the end of the class. So you'll definitely see some examples of there. And we'll be using, we'll show you a few things of how to create a template for Python code and Dynamo boilerplate. Pretty easy, but I thought maybe this would be useful for everybody since it depends on the user, how they want to do their boilerplate. So I'll give you an example how that works. How to use external editors to help you edit. I think some of you already are savvy to that, but I'll just give you a quick run through about that. How to test your code and review the outcome, and we'll be kind of messing around with that as we go. Debug the scripts, share your nodes, and best practice recs documentation. So that's going to be the general lesson plan. The vast majority of this class will be going through examples. Some of them I will just talk through. Others I'll be like, okay, guys, take out the node and let's screw around. Okay. So I'm assuming things will potentially go wrong. Hopefully they won't, but I respect Murphy's Law. So as we do some live coding, there'll probably be some live mistakes, and we'll figure it out as we go. If you're just struggling, like we mentioned earlier, post on the chat, and if we just can't see you on the chat, post on the Slack. You should all have access to the Slack for this class, and we'll have to do a breakout room, or take or at these 5-minute breaks every 20, 30 minutes. We'll try to do our best to sort it out, because it could just be as simple as software's not working, or you have a real weird problem. It could be that your installs or something aren't very good, and you just have to accept that. Hopefully everybody can work with us normally, but so should things go wrong, to keep the class moving in the right direction, we'll just have to potentially just keep working, and then at the end of the session I'll catch up with you. And of course everything's recorded, so don't feel like you're missing out. We'll just, you'll get the whole slide deck you see in front of you. I'm not going to hold that back. So everybody will get this and all the content related, so you can always go back and look at something if you need a refresher, or you couldn't because it was downtime. We'll do as much material as possible. I would like to get through it. There's a lot of these slides are pretty, there's a system to how they're used. So I'd like to go through as much as possible. So towards the last half of the class, the second half of the class, if I feel like we're a little behind, what have you, then I'll speed it up and maybe just talk through some of these slides and maybe save the live demos for the time we have left, so we don't run out of time. If we can't figure out questions on the spot, if it's something either that was on your mind, can we, what about this, what about that? We'll do our best to answer the questions on the spot. Do raise your hand so we can see what's going on. I'll try to go through the lesson first, like the actual explanation, as while people are trying to type or write notes. We will, I can answer questions, but if I'm like, hold your question till the break, hold your question until later, don't feel offended. It's just so we have time for everything. If you're stuck, an example, watch me work. Sometimes I can't get to you right at the moment, so just watch me kind of go through it, and we'll try to review together at the break. And we'll have, hopefully, I'm pretty sure we'll have enough breaks throughout the session. We're gonna have a check session. Yeah, so we'll have a break after the first. After I go through all this, and we'll talk about a few things, we'll have a break. So I'm gonna make a note real quick here. I'm just like highlighting my break sections so that we can have these nice breathers. Okay, cool. And I'll switch between the slide deck, Dynamo, Revit, and web. So if you guys don't know what I'm looking at, just ask me and I'll tell you what we're looking at in a minute. Or if whatever reason I have AV troubles and you guys can't see my screen, just let me know. And hopefully everything's good. Your Revit 2020 is good. Dynamo 2.3 or whatever version you're using is working fine. We don't have any kind of weird things where like some DLL on your install didn't go perfectly a month ago when you installed the thing, or yesterday when you installed the thing, and it's screwing up. Hopefully we don't run into that, because I've had it myself where everything should be running fine and it's not. Sometimes your 3D visuals in Dynamo background don't work, and that has to do with like graphics card issues sometimes. So it's possible that's all a problem. Hopefully not. If it is, we'll do our best to address it, right? So this is just to make sure we're all in good shape to deal with problems as they arise. So that's why we have, so the breaks will have 5-minute breaks every, like I said, 20, 30 minutes, and that'll be a good chance to at least look at some things. And if it's just, real problem, we'll do a breakout room. Okay. Preparation. Why use Dynamo Python? So I'll talk a little bit about the value of using Dynamo Python. We'll go from there. One of the things that Python's really good at is just, simplifying code. It's meant to be easy to read and can consolidate actions with repeatable cans, with loops, for example, and conditional statements, which pretty much any programming language can do. The beauty of it in Dynamo is it can really go a long way to consolidate your Dynamo script. And provide access to the API. This little diagram down here explains kind of process. You would use the Python script in Dynamo, which can then communicate to the API that can then talk to Revit. So it's actually a bunch of abstractions that do anything in Revit. So if you're wondering how this works, it's the node goes to the Dynamo wrapper, which is itself talks to the API, which itself then does something for Revit. So that's how many steps we're working on here to get anything done, which is fine if you don't have a ton of commands. People say Python, for example, is slow, what have you, which is true if you have like millions of data entry points to sort through or something like that. The speed can be a factor. I think in virtually everything we're doing in typical use in Revit and Dynamo probably won't matter unless you have a giant model, ton of stuff you're trying to process. But at that point, the bottleneck is probably Revit, or maybe not so much Python. So I don't think the typical limitations of the language would necessarily play out here. Hopefully these scripts shouldn't make any difference, put it that way. And one of the cool things, one of the easy kind of low-hanging fruit of Dynamo here is in Python is you could take something in this highlighted blue area and condense that into readable script on the right here, so that it's easy to follow. I don't like long visual scripts after 4 or 5 nodes. I check out, because sometimes the inputs come from left field all the way out to something far away, and your eyes have to track that. You can look down here how many things cross over. It's really hard for me to read, and it takes me like a minute or two just to even understand what I'm looking at. So it's always been a dilemma, whether any visual scripting environment whatsoever. It's always been a dilemma, especially in something with a BIM interface where there's a ton of inputs and outputs and data massaging and list management to keep track of. But visual coding, or textual code, I should say, makes it so much easier to figure out, because all you can just read this condensed section here. I can take this whole thing and make it to one node, and it says, I need a solid, I need a C, an X and Y, create a list of solids, and through here you can see what I'm doing with those solids, looping through some information, and the output solids. Maybe you're not going to be an expert at the first time you read it, but you can at least understand what you're needing to do without having to zoom in and look at the image. So even if you're not a pro at Python, or you're not a pro at Dynamo, this on its own, just being able to read the code, which is less than a couple paragraphs of code here, like 20, 30 lines, would be a big benefit to you as a developer of scripts of any kind. And anybody else you hand it off to, you can say, look at this code, and you can actually put notes in there to explain it. So that's a big win. And before we get started with the exercises, if throughout this course you feel like you're just not ready, you realize maybe this wasn't the content, you weren't ready for the content, I do have these resources here to get a little better at the basics. So we have Python Basics from Google, pretty easy course. I think you'll learn all the essentials there. We're not gonna do anything wild. Python and Dynamo generally is, nobody's doing anything crazy with Python language in and of itself. If you ever see anything wild, it's usually how they're interacting with either Dynamo content or Revit API content. That's where it looks a little crazy. The Python stuff is actually pretty straightforward. And if you need a little more brushing up on Dynamo basics, this is an old but pretty good class from Autodesk University, and Autodesk University has a ton of resources for Dynamo. This one goes over all the essentials of Dynamo itself, and there's a lot of, like, I think in the last 6 months due to the pandemic, people are just making Dynamo basics videos left and right. So on YouTube or whatever, you can find a lot of great training on Dynamo basics if you need a little more work on that. And there's even a Python and Dynamo basics. So this course is beyond the basics. This one will set you up so you can feel a lot more comfortable working with the node itself, basics of data types and all that stuff. If I say anything like data types and all that stuff, and you guys are completely confused, then let me know. But I think nothing here should be really that complicated. I should mention, so that Kobe had a question, Dynamo wrapper influence. Not that you would notice. If we're talking Dynamo wrapper, Dynamo is a wrapper around the Revit's core here, the API. In this case, I would say not really. You might see some things that would look like that, but it shouldn't really have an effect. I will mention that we're using the Iron Python implementation for this. Python in Dynamo uses Iron Python, not us. How that works is basically Iron Python is one way to read to a .NET environment, and because of the way Revit being a .NET environment works, we need something to interpret the Python code to .NET. And in a nutshell, Iron Python does that. So there might be, put it this way, in the coding we're doing today, you're not going to really know the difference compared to, say, just working in regular Python. It's going to be very similar to what you guys experienced, except for some quirks. That said, Iron Python is actually Python 2x. The most recent one everybody's been using for years now is Python 3x, which includes all those cool data science packages. So at the end, I'll talk a little bit about Python 3x. So it shouldn't influence anything. I would love to get into a deeper conversation about all this, but like every little topic along the way here can be a class. So if for whatever reason we don't, like, I don't address something fully or whatever, put it in Slack and remind me. I can probably, if I can't answer the question right now or like whatever, we'll follow up with you. You can even do a direct message to me on Slack if I'm totally just like not paying attention to your messages. In the sense of questions, general questions about how does this work, how does that work on a higher level. You can either put it in the Slack channel for this class or just direct message me and follow up. Right, so
wait, can I just say something about that? I'm just wondering, like, if I made a Python script in Grasshopper and I just wanted to copy it over to Dynamo, or if I just made it in a regular like IDE, is there some kind of modification that you need to make it work inside of Dynamo? Or, yes, if you're working in a, what do you call it, a .NET, an Iron Python environment, it should just work?
I'll show you in a minute, but the answer is yes, you would have to modify it. The basic statements are saying creating the variables, the values, and the operations like the loops and what have you. Those can be the same, but you have to modify your input. You have to modify basically the beginning and end, and you'll see that. So most of it you can copy, but you would have to adjust it. And there shouldn't be a world of difference, but it's also a learning curve depending on how you've learned it before. Basically, and you'll see this in a little more detail, but basically at this point they changed it very, very recently, like a month ago, but up to now we're going to use the legacy version, which is the nodes, the Python node in Dynamo. When you use it, there is no print statement. There's an out statement, which is like print statement. So it's kind of funny in that sense. If that's the same for Grasshopper Python, I believe. If not, otherwise most of the code looks the same. So
yeah,
let's do that.
In Grasshopper, you can still print to like a little output inside of the node itself, but the output only goes to the output section.
Yes.
So
That's right. And so for those of you who learn just mostly Python, not a lot of Dynamo, you'll see the differences as we go here, and I'll kind of hold your hand so that we have a good fundamental basis for that. And then as we get to more advanced examples, it's basically building on that. So we'll see the quirks along the way. Okay, so these are the exercises. We have more than a few, so like I said, if it ends up being like a ton of work, I'll start speaking through them. I'll say, okay, guys, I'll save like the good exercises for the time we have left at some point. We still have plenty of time, but should we start needing more time to, or should we run out of time? I'll be okay. I have to skip this. We're not skip, but we're not gonna do a live version of this. We'll just have to listen to me talk through, and then we'll save a few for the end here. But basically, it's going to be basics of the Python node, the basics of lists, basics of the for loop, writing stuff to Revit, using definitions of functions, unwrapping, which has a lot to do with the API, trying to accept features, because I think that's a useful code. It's similar to what you've done trying to accept in Python, using loop coordinates through existing graph, and then some problem solving. The key ones I want to look at is using the existing graph is pretty relevant, unwrap is pretty relevant, and hopefully we can do most of the first 4, and then if I have to sacrifice a few, oh well. So, and just FYI, if you guys aren't familiar with that, I think most of you are, indexing will start at 0, so that's how list manager works in, I think, Python and, Python, Dynamo, and Grasshopper, which is no coincidence. So if you ever see something, the numbers aren't matching, remember 1 in a list is always going to match index 0. So just as a reminder there as we move forward, which is why we have exercise 0 as being our first exercise. Okay. So for this one, we're going to open the Python node real quick, and let me just.
Is this file only compatible with Revit 2020?
Yes. Is
okay.
it? Hopefully you all have Revit 2020. That was going to solve 2 problems. One, I wasn't sure if everybody had 2x installed on 2019. Default comes with 1.3, I believe. So I was like, screw it, get 2020 because it has 2.3 installed by default. So if anybody having trouble with that, let me know and I can give you something in 2019. But hopefully you should all have 2020. So here's our beautiful building that we're going to design a little further. Open Dynamo. So we should all be familiar with that interface of getting to our Dynamo. 2020 by default is 2.3 installed, which is a pretty, not the newest version, but pretty decent. I think 2020.2 had 2.3 updated. So 2x is the latest main release of Revit, and they've been upgrading it ever since. And 2.8 just came out, so they've been doing it. They've been going pretty busy with making the updates to it. But 2.3, if you go up here, if you go to help, about, you can tell right there. So I got 2.3. If you're using, you might be using something newer. It really doesn't matter if it's exercise. It's not going to make a world difference. So that's how you can tell. That's 2.3. If it does a menu or opens up like which one, if you happen to have both 1.3 version, 2.3 versions, pick 2. I always recommend my entire company use 2. It's more stable, and there's a bit of a backwards compatibility issue. So I always recommend using 2 with everything. That said, what we want to do is find the Python script node. And I'm going to do this way. Python, if you just right click, you can type Python script and you want the first one, or you can just go to the library here and just go Python. So it's actually built in, you don't have to really do anything. This comes out of the box. And there it is. And the Python script here has a few unique features to it, in that it's very configurable. I'm just going to use the default looking version of it. So like any other node, you can just double click on it and change it, my script, and change it. These are all custom. Usually I leave alone because most of the time, whatever the text is for the node, I don't really want to change it. It'll confuse people. In this case, because this is literally your own custom node here, it makes sense to name it. So just keep that in mind down the road. You want to name it as we go. And I'm going to leave this Python script so you guys aren't totally lost in the example. Now, you can also, as you put inputs on the left here, these are all your custom inputs that you have to put in the code. And the output is on the right. So this is all expandable. So the more inputs you code into it, the more you want to have for the example here. And I would recommend everybody, as we do these examples, I think all the scripts I sent you should be manual. Just check to make sure they're manual, because sometimes they run and it causes, it could cause an issue. FYI, if any of you get into like warnings, the yellow box situation, it could be because, and even if we fix it, or like you think you fixed it, the memory, the code might retain some memory, put it that way, of like your last couple of actions, even after you fixed it. So at that point, you may want to just reboot Dynamo and just close Dynamo altogether, open it up, and hopefully it'll clear out its memory. If not, try to rebooting Revit. Shouldn't be that bad, but should you ever have a situation where it's like, why isn't it working after making it perfect? It could be that you need to clear out the memory, just shut down the program. It's a little, it's not as stable as say just running out of a text editor. So just keep that in mind. My example, if you double click in here, you'll get the script itself. So either right click edit or just double click on it and you can edit it. Yours is going to look a little different from mine. So what I'm going to do is bring back my presentation deck. I changed my boilerplate code. So all we're doing here is looking at what you have here. So what you see here, if you double click on it, is this text. If you're ever wondering what this means, if you're like no idea what's going on here with this note, this is just an example. They didn't want to give you a completely blank slate because that might not give you enough context. So the developers of Dynamo put in this boilerplate code that was like, okay, import your stuff here, and this is all Dynamo import, common language runtime of getting the CLR right. That's all built in. You have to really figure that out. But you have to, geometry refers to Dynamo, and so you can actually work with Dynamo. We'll talk about this more in detail as we go through. And then it's asking you to put an in node and an out node. And these hashtags have the notes, which are text to help you understand what you're trying to do in the script, which is always good to document, but won't actually run as code. So if you're ever wondering what this is when you double click on it, it's just the default boilerplate code Dynamo team gave you, so you wouldn't have to make it up as you went. And as you see at the bottom here, out equals 0. What does that mean? That means that's your print command. In this node, there is no Python print command. It's just out. So don't be intimidated by that. You just have to configure it a little differently from what you're used to, and you'll see in these examples how that works. You can even just delete everything and just keep it as simple as this. It won't change your code because everything else is either spaces or notes in the hash tag. And to show you how that works, you can type in anything here. So you can put in, hashtag. This is a note, and do things my way as follows. And you can then tell people what to do, which is pretty cool. You can, this is always something you want to document. And just about every programming language has some version of this. If you were using JavaScript or I think C# be //. So it's hashes in Python. And if you ever want to, I believe it works in this mode. I'll find out right now. If you ever want to do a bunch at once, you can do triple quotes. Let's see, import there. So if you ever want to just block out an entire section of code, you can do triple quotes. I'm not saying this is the most, kosher, safe way of doing it, but I haven't had too many troubles with it. It works in regular Python and this implementation of Python you see here in Dynamo. So if you're like, man, I don't know what's going on here, I want to block out entire sections of my code, maybe start over, just do triple quotes. And then you can block out everything in between the first set of triple quotes up here and the last set wherever you decide to end it. And then you can just keep typing away. So that's a useful trick. In this case, the imports here we'll talk about later. It's not going to really affect anything, but you can literally delete everything if you want to. And just start over. It's not going to affect anything. And until you can run it in here to see if it'll give you error, but you can also just save changes or revert. So that's the bit. So don't feel like you have to do whatever it tells you to do with the Python node. It's just there for you to screw around with as any coding language would. So with that, oh, thank you, Thomas, for giving us a cheat sheet. That's very useful. Maybe later on you guys can check that out. Good. So if you guys want to toss resources there like Thomas on the Slack channel, go for it. I think that's a great way for us to share information. I'm big on sharing. Okay, so we're going to do a few exercises, and together these are going to be very simple. And if you guys are lost, you can't pick up, just see how I'm. So somebody asked how you do additional outputs. You cannot. It's all just one output, as far as I remember, unless. So you can actually get rid of all your inputs if you really want to, but you have to have at least one. You only get one output. Outputs are interesting in Python node, but I believe I have not seen an example where you can do more than one, and I think it's just the one because it has to compile to one output. But you can get clever with it and try to do multiple things with the nodes, and we'll see some examples of that. Okay, first one to check out. I think we all have the same content. If you don't have it, again, it's in my Slack channel of the Amazon link. So I'm going to do is go to new. Don't worry about saving anything. Copy, open. That's my test. That's my live. One of the strings. Let's make sure I have the right one here. We're going to do this one. All right. Great. It's all in manual. So if you go to 00.0, we have warm strings, and I believe this is where my original example lived. So that's similar to what you guys have. I just deleted all the notes. And here, just go ahead and open this up. Actually, I'll just screw around with this. Let's go here. So in this example, we're just going to type it out here. So you could take an existing Python node if you want to follow my example. I'm just going to have this on my left screen. And what I want to do is create hello world. So how do I do this? Simple as you saw here, Python script. Put in 3 inputs because I want to do a code block. It'll be quotes for a string. String is a data type that's just text or means no numerical value, for example. And just for fun, we have to put a space there to get the sentence spaced out. And I'm sure most of you have already seen an example of code blocks before. There we go. Code blocks are lots of fun. So we're going to come back here into our node. I'm going to delete everything because it's going to be super vanilla Python right now. This has actually no way of interacting with the Dynamo node as it is. There's no imports or nothing. This is just generic vanilla Python. As you can see, as I type in strings, so my first value is going to be string 1. You can call this whatever you want. You can call this banana 1. It's up to you what you want to call that thing. And then you have to always use the in for input. So if you want to create multiple inputs, you'd always have to do IN capital bracket. Start with 0. You can always start with 0. You can do other numbers, but you're going to get yourself confused. So start with 0. And then if I want to do multiple strings, I do banana 2 or string 2, whatever you want to call it. So it's up to you. And then banana 3 equals input 2, and then I want to set the, okay, so set your output statement. We get our one and only output statement. And it's going to be out, so think print, but it's out. It takes a little bit, getting used to, but that's all it is. Banana, you could do the same thing if it was print. I'll show you what that looks like if you guys may have forgotten. It's banana 1 plus banana 2 plus banana 3, which correspond to my 3 inputs. I should put it here. Please add here. So save changes. Hopefully I don't have any hijinks. That's why I have my backup plan here. I put my inputs in order. I want them in there, run. You get the hello world up there. Do I get it down here? There we go. Nice. Hello world. Whoops. That could happen. Great. So it's that. So this is generic Python. You can do this in any text editor version of Python in the world. So don't feel this is anything new. It's very, very baseline Python we had here. So you don't feel like you have to import anything. You can just do these kind of statements. If you want to ever do just numbers or something like that, it's fully there. So moving it along, let's grab all that. And you see stuff like this where eyedropper, that's just my monocle tools. Don't worry if you don't have it. It's just my built-in stuff. The next version of this we want to try is a different take on it. And I should also mention that the print here would look like this. It would be print banana, yada, yada, the same thing. So actually, I'll just copy paste that. The print version of it will look like this. I believe you can use print statements, but it won't be an out statement. It won't produce an out node. They changed that a little bit at 2.8. We're not going to dive into that, but it does exist. It just, if you want to do an output, you have to do out. So just get used to using out. And depending on how you create your node, sometimes it can be, the out is just a statement, meaning it doesn't actually produce anything because we're using a function. So don't worry about that. We'll talk about that in more detail. So in this case, we want to type this a different way. So we already did the whole banana deal. So how do there's other ways we can do it. I'll just do a quick take on it. You can actually just do out. So we have to leave these statements. No, we don't have to leave statements. So we can do our triple quotes here to block it out. So I don't see this anymore, but you can then do out equals in. If you're like, I'm gonna cut to the chase. You can do the same thing. Input 0 plus, you can have quotes there, meaning a space. That's all we did there is create a space in the quotes. We're concatenating a string plus 1 plus quotes plus the last input. So we can actually bypass the whole value thing. If this is a very simple script, you can make it this way as well, where the output is directly, one line for the entire code. It can just be done this way. Save changes, will it work? Yes, it will. So you can actually write it that way. And you can also just directly inside Python, just write everything out. Kind of regret deleting that now. But I'll just borrow from the first examples here. I'll copy all this here real quick. It's perfectly fine to copy paste as long as it's consistent. For more complex scripts, I probably want to avoid that. And here, if I could just type in the words right here. I could type in, I'll just do in caps. Hello, space, world, space, exclaim. And I say, okay, now put these three together. Save changes, run. And I can take these nodes off now because they do absolutely nothing for this example. It's still good because, so I'm trying to show you that it's very flexible. Some of you have already kind of done something like this, but maybe it was just Python or whatever. It was ever Dynamo. The nodes they're very flexible. You have input statements in different ways of configuring them. You could also just write everything directly into your code. You don't have, if it's always the same value for the input, you could just leave it as such. You don't have to worry about putting in it from a code block. If it's like, well, I know it's always going to be the same 3 or 4 things every single time, just build it into your code. If there's no reason to have a code block or any kind of input for that matter, it's always going to be the same value no matter what. Or it won't change very often. You'd rather just change it in the text so you can keep track of it better. Do it this way. It's perfectly fine. And you can, and you can always copy this over and over again, right? And just, modify each one separately. So they're not like, the same. These are all independent. They're not going to, I can change one. Doesn't matter. They're not going to interfere with each other. So, but do try to name them so you have like, I don't know, API script 1, or like, you know, bananas, something that makes sense to you as to why you're naming something. So otherwise, just Python script everywhere. That's the default name. You're going to forget what this does until you double click. So make it easier on yourself. Either do that handy dandy Control W to get the new note. And if you don't like that, just put in there just something to identify, because default will always be Python script, but you're not going to know what it is until you dive in. So give it some kind of context. And I usually do something like PY to let people know, by the way, this is a Python script. So if it's just bananas, you know, make it, you know, PY bananas or bananas PY. So it's easier for everybody to read. So those are the fundamentals of the node. So Kobe asked, can you just do the input without having to? Let's use this example. So do you mean like just in? We could screw around, see what happens. Nope, it doesn't like that. So that's what I expected to do. It's basically saying it doesn't know what to do with this. It doesn't know what to do. So you do absolutely have to have that input indexed. And I mentioned before, if you're not using 0, but you started 1 or something like that, just make sure you match the input to whatever you built into the script. So sometimes maybe you copy this over and over again, you have like a ton of inputs, and you're not using every one. Just make sure they match from your inputs from left to right, they match the correct inputs. Did you have a question, Kobe?
No, that answered my question. Thanks.
And these are good fundamental questions, because this is kind of weird as far as Python goes. I think a lot of people are like used to like generic Python or somewhere else. So yeah, so you basically only have one option for out. You have multiple ins, but you do have to use that indexed version of it so to make this work. And I'll tell you, a lot of the time, if you ever run into errors, it's probably because something went wrong with your values, your inputs, maybe your output statement that wasn't working. It's very simple stuff. It's rarely like, you know, it can be where it's like you got the wrong, what do you call it? You got the wrong API call or something. 90% of the time, you type something wrong, or you didn't set things up properly. So it's good to kind of mess around with it and see what breaks and what doesn't break. So that was fun. Lots of banana shenanigans here. So we're gonna go into lists real quick, and I'll talk through this, and then we'll go through a quick example. I think most of you are used to the idea of lists, and this is a common way to manipulate data in any kind of version of Python, but especially Dynamo. If any of you have done Dynamo scripting or Python or Grasshopper scripting, or really any scripting, but let's say the two visual script meetings most people are familiar with in AEC, Grasshopper and Dynamo. Lists are a big part of that, and the more comfortable you are using lists with just generic Grasshopper or Dynamo, especially Dynamo, there's a ton of list management in Dynamo default. You saw that example earlier where you could consolidate a lot of the lists and manipulations of that list. That's where a lot of node work, a lot of this scripting spaghetti comes from. In visual scripting is just trying to massage data, whereas in Python it's very, very simple. In comparison, once you get the hang of how you can manipulate it, it's very, very simple. And the list can be called whatever you want, like I showed you earlier. They can call bananas, can call apple, and call cat. Something that makes sense. So it has some kind of logical thing, like if it's input 1, maybe 2 generic, it could be like if you're working on a specific project, you call like building 1 names could be B1 name. Something that's easier for somebody to follow what these things mean. So always try to be an advocate for somebody, either for yourself in case you forget, by adding notes and giving yourself clear values to these things, and clear names, clear text. But it could be any kind of value. And a list can be as simple as brackets, empty brackets is a list, saying we're going to create a list later. List with parentheses is another way of calling a list. And an example of just numbers is 1, 2, 3. That's a number data type, which processes it differently from strings. And you can actually mix and match. Lists are very flexible. So you want to get used to just working with them. They're not hard. You just have to remember the way you write them. It's going to be brackets or list with parentheses. And I could probably do a quick dive into it live to show you this, but you could do everything. You could actually create a list out of Python node itself. So if I were to, how is it? Let's just grab the original. Control V. Toss it over here. Double click and make sure I got this right in my example. Yeah. So you just want to set list equals brackets with some values. Out equals list. Let's do that. List. List equals bracket 1, 2, 3. If you guys want to follow along, go for it. And then out. Remember, we always need that out statement. For good measure, make sure it's capital letters equals list. Right. So it says whatever I put in my list, put in my out. Run the script, and there's my list. So if you just want to create a quick list, even you can do the code block version. You can use the out of the box nodes that make lists. But you can also do it in Python script. And you can even do the arrange, which is a step version. Let's say start from 0, go to 10 in 2-step increments. So it's very flexible. You can do it's all built into Python. Again, we're not using anything native Dynamo. And I'll open up this example real quick. Don't feel like you have to go at the same pace as I do. You can just observe pen string. This one. Yes. This one. We don't want. So don't worry about the one on the left frozen. So I named it append py. Another thing we want to learn is appending strings. So I have all my strings up here. You don't have to. You can, if you want, edit this on your own. I don't care. But the string one's just text. String 2 is a list of, or value 2 is a list of strings. Value 3 is a string, and value 4 is numbers. So you could just, and these could have been nodes like we did earlier. It could have been nodes on the left. I just built it into the code. I said, give me a list. So yeah, I put list equals blank. So how do I get anything out of this? I have stuff here that I want to use in the list. I have a blank list. So how do you do anything? Well, if you're familiar with Python at all, you can do the append, which says, do a list. Give me one list that does append string 1. Give me another list that does append string 2, and give me another list that does numbers. So I'm telling it what I want to go into a new list. Just this append command. If I want to make a brand new one, did I do string 3? I'll just do string 3 for fun here. So if I do list command dot, I see how it gives me some previews. There's some nice autofill features here. It's not as robust as a regular IDD. You can just type append, and then you can do string 3, for example. So that's as simple as that. You just have to get used to this. So I'm just going to quote that out so it doesn't work out. By the way, you can use the hashes here to block out text so you don't have to run it. Try not to do that too much. Once you're kind of happy with what you've resulted in the Python code, come back here and delete stuff like that. So you can either comment it out, meaning I could just make the code inert and maybe save it for later as I'm trying to study this script and make it work, or like you realize you don't need this anymore, just go ahead and delete it so you keep it clean. This is all about keeping everything organized and clean. And I put my out, and in this case, say, give me the list. See, now list is going to append me 1, 2, 3 things into one big list. And while we're at it, give me string 3 as a separate list. So you can, it's pretty flexible if you want to create a list of stuff out of here, either built into the code itself or coming from indexes on left node, however you want to do it. So you can go save changes, run. Run on its own doesn't really cause anything to happen. I think I'll just run to see if it gives you a warning, but it should be fine. So if I go here to manual run, right, that's what you want. It'll then result in the list. So remember, we created a list, right, at the top here, and it gave me it gave me all lists above it. So let's compare the two. So I have lists. Give me this is empty. It's a blank slate. Put this appended stuff in here. So we have string 1 is the beginning at the 0. So I have the master list itself, and then I have nested in that the beginning. Then the next one, list, the append number 2 is the list of strings, which is all the fish. Then the next one after that is nested with the numbers. And then at the end here, string 3 is separate. So the big list, as you see here, contains all the appended lists that I told to put into the brackets, the append, and the string 3 just comes after all that. If this is kind of wonky to you, don't worry. It's 4 levels of nested strings. Just realize as you want to create something, you could just tell Python to append stuff. So, and you will be seeing similar things going on. You may have to review this a little bit, do it yourself, but it's actually a pretty straightforward concept, whether you're doing just regular Python or in any kind of node environment. So realize you can actually just tell all the inputs to go into a list. That list can either be an output or used for another portion of this code. We're keeping everything very simple today. And let me see where we are. So we'll take a 5-minute break since we're an hour into the class. All right, let's continue. So the next thing I want to show here is looping. Looping is the level up from creating lists because it can create lists for you faster. Just a refresher for people who aren't familiar with loops, basically they're fundamental in any coding language. You'll see this just about anywhere. Same concepts with values and lists that are structured to create outputs. But the difference of the loop is you can create a statement that just iterates over a sequence until you're done with the sequence or something happens that you have to move on. So you start with some kind of iterable, like a list of, like we had before, 1, 2, 3, something like that. You then give it instructions, and then the instructions check, does what I need to do the loop exist? If so, yes. Then do the instruction. Then whatever I tell you to do, do it. And keep doing this loop over and over and over and over again until either there's a statement I tell you to stop or just end the loop. Very useful to, so basically Dynamo on its own doesn't really do looping. There's a workaround to it. I don't like it. I don't want to use it. I'd rather just do it through Python code. That's one of the limitations of visual scripting is looping is challenging. Any kind of conditional statement looping, conditional statements maybe, but looping is very, very challenging. We'll see the benefits. And we have a little animation to, oh, come back. Where'd it go? We're going to show transform, display settings, swap view and slideshow. No, shucks. Okay, I'm going to minimize this real quick. Oh, you guys can see that now, I think, right? Swap. There we go. Okay, so you can see it happening here. For I is a variable. We'll talk about this in a minute. In the range 0 through 10, print I. So everything between 0 and 10 printed, and you can see it happen on the right here. So you can do it again. Will it run? Yeah, there we go. So you can see for I print, for I print, for I print. So it's actually literally going through it for you and creating a print statement. So that's how it works. And then you could do nested loops. I can run one loop, then do another one, and another one based on the initial range. So I can actually keep repeating this and say the total. So you have, and again, these variables, you just assign them. Again, I can be banana 1, J can be banana 2, K is banana 3, whatever you want to call them. But I, J, K, I is for iterable. So this is the jargon you see. It's whatever you want to call it, but range is your range. So you have to know which ones you have to actually have a correct value and which ones you need to just make up a letter or a word. So for every time I do 0, so everything in the range 0 to 4, I didn't put a step, so it's every value integer between 0 and 4. I'm doing that over and over again for I, J, K, and then it says, okay, my total is now I, J, K. What does that mean? It'll just keep looping through this, and you can see the values on the right there. It's creating a print total based on all the values. So it's 3, 1, 2, 3, and then it's going to keep looping until it has its total range. So this is what it does with loops. You can actually then tell it through a very, very basic sequence to keep looping until you have all the values. So you don't have to put this in yourself. It's like, look, I want this range, go figure it out, and it gives me 3, 3, 3 as the final output. So the benefit of that is I can then start mixing and matching. For people who are familiar with Dynamo, you can do what they call a cross-product list to mix and match, but you can actually do this in Python as well. And this is what it looks like in Python. So I could take a list, concatenate the list, or create a list of, or I have inputs going to a list, and then that can go into Python. And let's say I want to mix the building names with the discipline names. And all you gotta do in this case is just do what we did before, create the index values, and then say set to a list. Last time it was brackets, this time it's just list parentheses. They're both basically the same thing. So I just want to show you both examples, so you know there's more than one way of writing it in case you have to copy somebody else's code or use somebody else's code. You want to get used to different ways of somebody might write these things out. So I'm saying I got 3 values here. 2 of them are inputs. One is the final result of the list. I'm saying for BN for building name. Remember, I made that name up. There's no, I can name it anything I want. For BN and building names, do the next step, and you want that colon. 90% of your Python errors come from now having the colon or indent. I'll show you that example real quick. For DN and discipline names, go through that again. And the out list is append some concatenated strings, meaning put BN together with a space to DN, give me a list. Let's see what that looks like. Hopefully I actually have it open here. Oh, I don't. That's all good. Wait, I want to use this as an example. Let me just run this real quick so I don't lose my mind. Wait, don't worry about this. These are bonus points. Loop strings, here's what we want. So again, you should all have these 0, 2.1. It should all be there. And this is all very generic code, so it shouldn't cause any problems with opening and running it. All right, so we have the example we just saw here. Again, Python script here. I have the building name value. And if just for fun, I have the building name value, discipline name value. So I'm saying iterate this value. It could be I. I can change it right now, J, and then I can make it I, J. Don't feel like this is stuck in time. I literally made these names up. It's whatever I feel like making them. It says for every value in building name, which is these, and for every J value in discipline name, which is these, append them to the list in this order. So if I run that, what does that look like? It mixes them for me. It says, okay, I'm going to first go through all the iterations and then a building names. And each time I do a building name, I'm going to put a discipline name in there. So that's why building 1 has all disciplines. It had to loop through building 1, then it tossed architecture, structure, mechanical, electrical, plumbing through every time. Because again, discipline name is listed in building, is a nested in building. So if I switched it around, it would have been architecture and discipline names, then the building names. Simple as that. And then I just told it to output the string. If I want to do something different, I don't know, triple exclamation points, for example, you'll see that change. Put that in between the building name and the architecture and discipline name, spit out the list. Okay, so I'm going to save changes, run, and there it is. So it's that simple. It's very flexible, and this is a good way to create a list if you want to make sheet names. There's plenty of ways to do that in Dynamo out of the box, but this is just an example of how you do a basic loop. This is what they call a for loop. There's for loops, there's while loops, there's break statements. We're not going to get into all that today, but this is a good starting point. And next one, don't worry about the code blocks. This is just consolidation. It's just lists here. I just want to make it a little cleaner. So there's nothing here you have to worry about. It's basically another list. Unfreeze it. If you have it frozen, remember, unfreeze. I did that so it wouldn't run. The difference this time is we have 3 values now. Before we had just the 2, right? 1, 2, 0, 1. They have 0, 1, 2 for all the disciplines and levels. So the one thing I threw in there now is we have levels. So now I want to make sheets for every building, every architecture, or every discipline, every level. And all you gotta do is toss in one more loop, 4 loops. So I'm gonna start with buildings, then I'm gonna do discipline, then I'm gonna do the level name. Same thing, except this time add one more value iteration, give me an out list that's gonna append all these. Bada bing, bada boom, run. Now I have 125 values, which makes sense. 5 times 5 times 5. And then you can take this and use it for something else. You can put it into your sheets or whatever. So the more involved you get into these kind of loops and lists and everything, the more you realize how beneficial they are, because you don't have to rely on Dynamo to do this for you. Again, another easy win. And make it clear, if this might make sense to me, if you gave me this code right now, or something similar, I would not have too much trouble understanding it. It's very clear to me. But if you wanted to help somebody out, you could put, values from the project information, right? So that they know it's coming from. Append to this empty list the loop below, and then I say that's the loops for each part, building, discipline, level, and then outlist is your outputs, and use this for sheets, right? So you can do it this way. Just, yeah, and you can say Python script again. It could be list loop. We'll keep it simple. Py list loop, something that's logical. That if you ever had to come back to this in 3 months, a year, you're like, oh yeah. Always throw a little bit of love out there for yourself and other people when it comes to Python coding or any coding for that matter. Just throw some context. This one itself is not hard to figure out if you're used to it. It's pretty straightforward. So I recommend for anything that's like, okay, maybe somebody won't understand what I'm talking about, just throw it in there. It's always going to be documenting. Always be documenting. Yes, list comparison should work. I don't think I have an example of that today, but that should be in there. Yeah. And I should mention to everybody, don't take my examples as being the end all be all. There's 1,000. If you have to, at the end, we'll talk about some examples of how to find stuff online. The reason I even learned all this is because I saw so many good examples of Python coding for Dynamo online. I'm like, screw it, I'm gonna learn this now. A couple years ago, there's actually a ton of examples online, so you can. Just don't think what I'm doing here is like the beginning and end. Most of the things you can do in Python, you can do in Python and Dynamo. Most of the things you want to do in the Revit API, you can do with this system. And if you're ever like wondering, can you do X, Y, and Z? You probably can. Just you do have to kind of experiment or look around a little bit, ask around, forums, what have you. So let's go here. We did all this, did all that. Okay, we finally get to the fun part of finally having this Revit model open is to write. So we did all this stuff everything I showed you before was generic Python. You didn't have to use Dynamo to do it. I could have done it in a regular code editor, right? Now we get to have a little bit of fun and do the Dynamo stuff. So we're going to write some elements. First, no, we're going to do them both, actually. It's going to be showing you both in Dynamo and in Revit. And what we're going to start with is exercise 3 value. And this should all be built in, I'll show you. But what we're going to do is 2 things that could finally start gluing some of these pieces together. Is we're going to create a simple node that will place a single column inside your model. We're going to use 2 real Dynamo inputs. Up to now, it's just been like text. So we're going to use family text levels. This is all built into the node, so don't worry about making this yourself. And we're going to reference within the Python script a node from Dynamo. So this is where we start kind of doing a little bit of deep dive into the session. So let's go open 3.0. And the ones on the right here we'll move on to when we get there, so that the inputs aren't there. And these are all default inputs, but now we'll start showing you the example. So let's look at this Python script in number 3. And there's one difference here. It's the imports. You can see, we have the values again, and we have an output. But between the import statements and this column statement here, which is a little different, this is a more typical of what you expect to find in a Dynamo node. Now, totally legitimate if you just want to do some list manipulation, data manipulation, list comprehension, loops, with just some plain text data, number data in Dynamo. With Python, just vanilla Python, you can do that. It's totally fine if it's useful to you to create some kind of value. But if you want to work with Dynamo itself, you need this import statement. Import CLR, and then CLR add reference. If you had to type that out yourself, it'd be, CLR.add, see how it pops up, and then you have to then know the string proto-geometry because that's a string. That just lets you touch 2 things. The proto-geometry, which is the geometry engine in Dynamo, all those 3D previews you see in Dynamo down here, as proto-geometry, so you could actually interface with that. And Revit nodes, which is the node library out of the box for Dynamo, which is all the, if you want to get a little more clarity on that, what does Revit nodes mean? It's the literal Revit nodes vector. That's what it's referring to. Just like family. So I want to use this one, family instance. And family instance by, of course, there's like 1,000 nodes in here. So if I don't find it right away, don't worry. But it's level by, well, it's in here. It's a by point. And of course, there's a lag because I have too many packages. But basically, that Revit statement in there, let's X out of there. So I got a little bit of lag on my side. The bimorph nodes are not playing nice today. By points. Come on. And level. So if I right click on it, you can go to help, and you can see it's revit.elements.family instance.create. So it's actually built in. So you do need to see it. Sorry guys, I'm distracted. Sorry guys, one sec. I lost something here. Sorry. So I want to use this node. See how it could be outside, floating around? We can actually put it inside a node, the Python node. You could just set family instance.by point and level. And see how I have family type, PVC, and level? That's corresponding to the nodes on the left here. So that's how you can actually build in to your Python node, your Dynamo node. You can do this for any Dynamo node, as long as you know how to use the node and call it in the script. But that's what we have to do, both the import geometry, proto-geometry, and Revit nodes. I'm not expecting you all to understand this immediately. You don't have to be experts at it. There was a question about lunchbox nodes. Don't worry about it. There should be no package nodes here. Don't worry about that. This should all be vanilla JavaScript. Excuse me. This should all be vanilla Dynamo out of the box stuff. Packages on the left here are just stuff I have laying around. So there should be absolutely no, unless for one script there might be, but don't worry about that. For this example, there should be nothing to worry about, so don't worry about packages. That said, as long as you know what you want, you can actually bake into your Python script whatever kind of node you want from either Dynamo. Okay, so but to make that work, you have to import, and you might have just I highly recommend learning more of this. I guess once you do this class, just learn more about how imports work. This is true for any Python, for any kind of coding. You'll have import statements. And this is pretty normal for any coding language. I don't think it's unique to Python. Most coding languages have imports. And you just have to get used to how that works. But all that means is so you don't have a muddled up code. You say import the CLR, which adds the Dynamo library, basically, is one way to describe this. And from the add reference, proto-geometry, add a design script, and then import asterisk, meaning everything. Risk is everything. Sometimes everything's too much, but in this case, meaning it might, if some of these modules from these imports we're talking about here have the same names, you might end up having conflicts. So that's something to troubleshoot down the road. You shouldn't have any problems today. So I would recommend learning more about this. Again, this could be its own class about how this all works, how you can import statements into Python with Dynamo, what they mean, how they work, how that affects your template. But just realize this has an effect. If these aren't here, you can't then use family instance down here. You can still use other aspects, but you can't use point by coordinates either. That's the other point by coordinates. If we do point dot coordinates XYZ, same thing. So I actually have two Dynamo nodes in here built into it. So you can actually, again, build in anything you like. The family and level are those indexes here. Because they're inputs external, I have to give them the index values. And again, I kind of make up the names as I go. You can call them family type, you can call them level, just to be logical. But because I built in the point by coordinates, I just summarize as PBC. It could be whatever. It could be X, Y, Z. It's fine. You can name it whatever. Just name it something logical. So I just call point by coordinates PBC. And then I want a column instance. The family instance by point level will give me my column instance, right? And just to spell this out, so you can see this live, if I were to, let's say I have to hash this out real quick. And if I did PBC equals point and by, see how I put the dot there, by coordinates? So it actually brings up for you. So if you know what you're looking for, if you're like, okay, the node I want to put in here is point dot by coordinates, as long as you do the imports, it'll figure it out. You can actually literally type it out, it should find it. And then remember, coordinates X, Y, Z, zeros, so 0 is X, 0 is Y, and 0 is Z. Why? Because it's just the same sequence. You have to get used to the different ways these zeros pop up. Sometimes it's literally just 0, 0, 0. Sometimes, like as in a list, sometimes it's like this where it substitutes X, Y, and Z. You'll get used to it. Don't worry about that. And what we're saying here, and then the column, as I put column for CLL for column, put a column here. So what happens? This would also be, you know, you could put a generic 0, 0, 0 here, but it's actually, so I'll do this one more time. Column equals family instance dot by point and level. So you just arrow down, click on it, and you can, if you didn't know anything, you could put 0, 0, 0. But because we already have these substitute values in here, we're not going to do it that way. So we're actually going to tell it for the family type, put in the family type input. For the point by coordinates, which is the point, X, Y, and Z, put in the PBC value. PBC here, put it in here. Pretty cool, right? You can just tell it directly, once you create a value one line above, you can then tell the next line to include it into its values. And level is the next input. You just follow the exact same logic in the node. And you can do this for many, many different kinds of nodes. It's pretty flexible. And so let's delete that. So that's where, otherwise you could put 0, 0, 0, some filler. All right, so we're gonna activate this now. So what do I have? The family type, you can go along with it too. There should be all these in here for you. So I could pick rectangular column, level 1 should be fine. Move this out of the way. And it says, okay, put this column at level 1. I have to, because it's and remember how Revit works. If your family type, like a column, if your family type, like a column, is constrained by a level, make sure you include that, or otherwise you might have problems. Then I already put everything's default 0. Save these changes, find out what happens when it runs. It's spit out, so you can actually get a list. It says, I got you one value here, 18 by 18. If I go into geometry mode, you can see it. It came up at the default location, 0, 0, 0. So I actually wrote a column into my model, and the element geometry preview highlights it. If I go back to Revit, there it is. There's my column. So you're thinking that's pretty cool, but I could have done that anyway, which is true. So what we're going to do here is right-click freeze it so it doesn't come to play later. Go to our next one. We're going to do the same thing. Column 18 by 18. And the only reason I didn't connect the nodes so nothing would work. So you can connect it now. And don't worry about the warning. What it says here is I didn't get anything out of this because we didn't connect a node. If you ever see these warnings, sometimes there's some serious jargon that's hard to understand. Sometimes sometimes you're like, oh yeah, I didn't connect the node. So just kind of, there's a zen to this. So don't worry too much if you see it along the way. And what we want to do here is change things up a little bit. And instead of using, so I'll do a side-by-side comparison of the original to this, which is kind of neat. You can put two scripts together. So on the left is the first one we did, on the right is the next one. What's different here? The import statement is all the same. Family type and level is the same, but I moved, and actually point by coordinates, if I delete this, that's the same. The difference is I did a loop. So like we did in the list exercise last time, it's yada yada for yada in range, whatever. So what I'm doing here is then setting my values for a list, so I can create a more variations on this. So that I have for every value in the range 0 to 100, and these are in feet. If I'm doing this in like a metric version of Revit, it will automatically convert to, I think, millimeters. So just pay attention to what numbers. These are in feet. For 0 through 110 10-foot increments, put the value x in x, point by coordinates. Before it was just generic x, right? Now I'm saying go through 0 through 100, 10 foot, so that's 10, 20, 30, 40, so on. Put that here in x, leave y and z alone. And for the column, same thing as before. Whatever the PVC ends up being, the family type and level, tell in there. So one thing we're actually changing is a loop. We nest these values after the loop, and we create the x value out of the range. I tell, okay, point by coordinates, I'm giving you 10 coordinates now, starting from this range. Append that, and the output here, I should have mentioned, we also have the output. Before, there was no real need to have a list, now we have an output list. For the list here, append the column value so that we can spit out a bunch of columns. Okay, so it's going to be all the inputs and values. I'm going to do a loop, nest statement. Remember, it's going to be, if you don't have that colon, it's going to screw up, so make sure you have the colon. Indent, point by coordinates, whatever x ends up being, please put that in my x value. And again, it could literally be banana. Okay, banana, just make sure you write it consistently, so don't use banana if you're going to do this for real. I'm just trying to make it clear it's what this means. So every time banana iterates, put banana in here from x value, and then column will get me, once that's PVC is done here, it'll put in PVC here with the family type and level. Append all of this to the output, and then spit out my output. Save those changes, close this to run. Hey, look at that. It gave me a list of columns. It's either, how many did I get? Let's go back here. I got 10 columns. Yeah, 0 through 9 index, so that's 10. So, and if I want to go crazy, I could put 1,000, which will give me 100 columns, right? But for the sake of time, I'm not doing that. And if you go back to Revit, there it is. It's a list of columns. Okay, so we're seeing how we can keep using the same code and just modifying it. I got a question about, is it using internal Revit coordinates? Yes. So 0, 0, 0 here is 0, 0, 0 in Revit. So it's you have to keep in mind where you're loading all this in. So there's different ways you manipulate that. This is like a very, very basic example. So yeah, 0, 0, 0 is the internal coordinate system for Revit. So just keep in mind where everything's being spit out. If you know exactly where it is, great. If not, this is the starting point. So on to the next example. I'm going to freeze that one. Great. And that's a good thing to do along the way. You can either take the inputs out, or just, I would prefer freezing it all together so the Python node doesn't work. So it doesn't give you too many versions. Then we come here to the next one. I have an XY matrix. Same thing. I go to my favorite column, put it in, so it doesn't give me this error again, because it's like, I have no idea what you want me to do because you didn't get an input, that kind of warning. And I'm going to do another comparison one more time. And that's going to be, so what do we do this time? It's actually very similar. Input family type, input level, point by coordinates 0, 0, 0. Output is a blank list. I'm going to append, and x/banana in range. This time though, what I did is I added another range. I just nested it in. So you would, literally do indent, come here, tab. Again, 90% of your mistakes in Dynamo, or Python, I should say, come from not having the colon and not having the tab. Believe me, it's happened to me way more than I want to admit. So pay attention to those for the syntax editing. There's a lot of your problems come from, like, you didn't capitalize something, or you in fact should have used lowercase letter instead of capitalizing it. Just pay attention to that as you practice on your own. And then I do the same thing. I literally just copied this statement for the X loop, put it down here, and I just changed X to Y so we have a different iteration. And what I do, remember last time I had banana stand place for x. Well, now I'm putting x and y. So every time you go through these values, put them in the point by coordinates. Everything else is the same. We just nested everything below y so that once x and y is done, then we do the rest. So remember, nesting is a hierarchy. If you want the x and y to take effect down here to the next level, you have to then nest them all. So keep that in mind as you go. It's just what do I want to do first? Okay, great. Next is then nest the next part. If you want that to be following the first part, then keep nesting until you're done. Okay. So we're going to run this, see what happens. So now I have a grid, 10x, 10y, and it basically did a cross product. And again, I can make these any numbers I want. It could be 1,000, it could be 2, doesn't matter. So you can just change these on the fly. And for fun, I'm going to see if this works. Cross my fingers if I get this wrong. But I can probably change that as well. This is just 0, 0, 0. Can I run that again? Will it change? No, unless it did. But you get the idea. It's running in Revit over here. I think I have to maybe reset that if it wants to. Oh, here we go. Oh, here it is. By the way, this thing floats on its own, so it can go off the screen. So if you ever lose this, just go down to Revit and see what's open. It's all Dynamo script stuff. So, oh, I didn't save it, did I? One more time. See if I can show this example on the fly. You guys go crazy and change as much as you want, but be careful. The more values you add to this range, the longer it'll take to operate. So hopefully it doesn't give you any headaches. So, interesting. Oh, don't worry about it. Oh, that's a troubleshoot for that day. So freeze that. So we're going to be a little more ambitious, and this time we're going to use a little different syntax. Instead of using family by point and level, we're just going to do by point, so it's not constrained by the level. So we can do a little more iteration. So basically the same thing. I took the level out because we don't need it in this case. That's the only reason you only have one input. You still need a family type. And same thing, 0, 0, 0 for point by coordinates. Output is a list. And we have one more nest, same concept, z. So do x, y, z, and point by coordinates gets x, y, z. Column is then written by family type, and then point by coordinates, which is now a z value for a full 3-dimensional system. Append that to the output, spit out the output. And if you want the value here, I believe it should be loaded in your model. This is the only reason we're using especially here is it's unhosted. Let me make sure if I find the right one here. Should be kind of cheating. Come back here. Sorry, make sure I have the right family. Control F. Control F. Oh, don't click on that. Control F. UH. Gen UH. Yes, that's what I want. So if you want to find this yourself, let's go down to G. G. Where are you? Oh, there it is. So under fixed and form, you'll get gen. You can select that. Toss it in there. Let's see what happens. And oh yeah, one more thing. Instead of, again, because I wanted to use a different node in Dynamo, I changed the column to be family instance.point. That was the only difference. And there's no level here. So if you ever want to like reuse your code and modify it, just remember what you're trying to do with it, with either nodes or Python or whatever, so it can behave consistently. Okay. So run that. Yeah, it might be a delay depending on the computer. And look at that. I have a whole 3-dimensional system of points. And it spits this out into Revit. So if this could be useful if you're like, man, I really need to get a ton of models in there. This is an example of how you can do that with Python and Dynamo, where you can, instead of creating multiple strings or multiple nodes and all that, you can actually manipulate it pretty quickly in Dynamo using the same base code. So you get the idea. We're trying to use basically the same concept from the very beginning, modify it a little bit, give us lots of options to edit it, and then use it for this output so we can then have all these models. And notice that the last set of columns are gone. Since we're all in the same script here, it will replace whatever the last iteration was with the new one because it's taking as the same operation. So if you want to keep everything, you'd have to, I believe you'd have to run a different script. So either save this and close it out, or just make each one of these steps a different script if you want to have all of them written down. So that's the nesting, and that we finally got some stuff written into Revit, which is pretty cool. And so back here, the next step, let me see what we got here. Okay, so we'll do this. Next step is called wrap. So what we did the last exercise, exercise 3, was add things to Revit. They're brand new, so we just toss it into Revit, it's all good. But if you ever want to edit something existing into Revit, you have to know how to wrap and unwrap it. What that means is it lets you access the elements in Revit, because right now, Dynamo, being a wrapper, can't directly modify the elements in Revit. Now the nodes, all the out-of-the-box nodes like write to parameter or edit parameter, that'll do that for you. It's built, so a lot of these Dynamo nodes can take care of this for you. When you do this in Python, you make your own Python node to do this kind of stuff. You have to have the wrap and unwrap. So there's all this documentation here. The key text in this example is, there's actually more than a few, but you want to use transaction manager. So in between here, ensure and transaction and transaction task done, it'll be your code goes here. All that looping and all that stuff would go here. Everything before would be just calling in more references libraries, and also spelling out the document manager, meaning this is all going to help you modify the existing Revit elements. That's the best way I can explain wrap and unwrap. If you're adding brand new stuff like we did in the last example, like those columns to Revit, you don't have to worry about this. If you're going to modify stuff in Revit that's already been there, you have to use this method. And I'll just talk through this. I'll just talk through it. So in this case, it's a slightly different take here with this, and this is spelled out. So you always import CLR, by the way. I don't think there's an exception to that when you're either using Dynamo nodes, Revit, editing directly with the API, or any combination thereof. If you're just doing generic Python coding, you don't have to worry about this. So you always import CLR, and then from there, you import add references, Dynamo, Revit services. You have to then, from the Revit services, add import document manager and transaction manager. And then you have to set a value called doc equals document manager that can then go into the transaction parentheses doc. So this is going to be boilerplate. Since it's all basically the same, you don't have to memorize this, nor should you have to type in every time. We'll show you how to do boilerplate in a minute. But the big difference here is the elements that go into your input, index 0. You have to, that means any element that needs to be modified. So if from Revit, right? So keep thinking about like whatever element needs to be modified has to have this unwrap statement in parentheses, and then you do the input in brackets. Again, it'll take some time getting used to these kind of this jargon, this language. So don't feel like you have to memorize this all at once. This is just, there's reasons we have notes. Just get used to the idea that if you want to modify elements in Revit with Python node, you have to do these. You have to have more code to explain what you're trying to accomplish, and change your syntax a little bit in the code so it works. So if it's unwrap, meaning I want to edit something in Revit, and that could be a lot of things. It could be schedules, elements, whatever. I want to touch the Revit model, existing content. If you're reading from Revit, that's low. If you're just reading, but if you're trying to write, edit, whatever, this is where it comes in. And then you begin your transaction, meaning, okay, now I want to make changes to Revit. Put all my code here, all the loops and everything, put it in here. Once you're done, and then you have your output. So it's a different take on it. And we'll show you a way of doing this, which is kind of neat. So I'll open up exercise 4, goodbye exercise 3, unwrap. And I believe Python script here. So you already have that example kind of spelling out what we're doing here. And what we're going to do here is go to this Python script, double click it. I cleared out the notes because it's basically the same thing on the left. Very, very simple version of this. a lot of examples you might see online, the vast majority of examples, if you go to Dynamo bin forms, for example, or any website that uses Python nodes as an example, you'll see a lot of transaction management. And this is all it's doing at the end of the day, is it has to add the doc value, otherwise you can't do the transaction. And see, you have to unwrap the elements. So see how it's different. Before it was, it would have just been elements. I'll just type it out here. Up to now, we've done elements index 0. Remember that? Up to now, it's been like that. If you want to, again, if you want to modify something, write to it, or actually write, edit existing content, you have to put the statement unwrap. So unwrap elements like that, and see how it's kind of subtle, but you can see how I highlight it a little bit. That's how I know it's active. So that's how you have to do it. You have to put the in statement with the bracket inside the parentheses for that to work. And that'll be your input. Then you put in transaction.instance.ensure and transaction again. If you were to type this out, transaction manager.instance, it'll help you write it out. Ensure in. Stop popping up, but don't worry about that. Transaction.doc. See how it highlights after I do the print? I finish. It pops up a little bit in highlight, bold. So you can type it out, but this is pretty much always going to be the same. So you want to put this in boilerplate. Then you put your code in. Now we have another loop for iteration in the element input, colon, next one, nest, tab, doc. In the doc, dot delete the ID. All this means is everything that goes in E, iterate everything I gave you in E, and delete it. Delete is an actual command. It's not just some generic text. When you see that point like that, that's when you know it's something that's going to then call up an actual function that does something. So you have to pay attention to what's like random text like this. You're going to call this EL or whatever. I can make that up as I go, as long as it's consistent. But delete's an actual operation. And then for every iteration ID that I get, so dot, I think I can do this now, dot ID, it's not, but that's fine. For every ID in the iteration, delete it. Then put down done, this statement here, you don't have to put document anymore. And then my output is actually not going to be an output. They're going to be deleted. So it's a string. I'm saying, for my output, give me a message saying we're done here. So again, don't feel like you have to memorize this all at once. Just understand the logic of how you would use the unwrap. So how would I use this? Because Dynamo likes to be interesting, we're going to have to move the Dynamo window down somewhere else. Come back here. I'm going to undo. I'll just select. I'm going to clear this up a little bit. So I'm going to select all my awesome cubes here and delete them. Then what I want to do is just select the furniture. So we're just going in Revit here and selecting stuff. And you can use your handy dandy tiny little glasses tool, isolate elements, and just isolate them, because we're going to then come back here to select elements. All right, so I'm going to move this window down so I can actually select them. This is if you want to select. If you know, you can use filters or whatever. There's all sorts of ways you can get this into Dynamo, but for selecting it, you can do it this way. So I selected all three of these elements, and we're going to run it. And so there's nothing selected, but it does say done as instructed. And look at that, they're all gone. So what I did is I gave it these inputs, these elements existing in the model. And I'm like, hey, every element in here, run through it. If it has an ID, delete it. And they did have IDs. What's neat about this, if I undo this, they're all pinned. So normally you have to unpin, delete. In this case, you can cut to the chase with these programming. I just delete it, which is pretty cool. You can make this into a tool and say, guys, here, select that. You can give this to your team. You can use it yourself if you ever have stubborn things that just won't delete, or like I don't want to deal with deleting these one by one or unpinning them first. You can select all the stuff you just want to delete and run it through this as long as it has an element ID, which just about everything in Revit does, and just delete it. So it's a pretty cool tool. Very simple to read. This is easy to read. You can put notes in here. You know, meet all your Revit elements that were selected, right? So simple as that. And I just make it clear to people, no output because it's deleted, just a message. So that way you know it's finished. So simple stuff. That's, but if I didn't do that unwrap statement with the elements, if I didn't have the transaction, if I didn't do doc, this would not work. It would be like, I don't know what you want me to do. And let's see if I can force that. If I hash that out, let's see, and we'll do this select one more time. So it has the element IDs, right? Stretched out. I'm going to run it. What does it say? Doc is not defined, even though so if you don't have doc, you cannot then use doc in the transaction manager, nor can you do it in the document deleted. Document means your Revit model in a nutshell. So make sure this is all lined up, otherwise you get those kind of errors. Actually, I should save. Okay. So again, there's lots of examples online. This could be a whole class on its own, but we got to keep going. So don't feel like, if you feel a little overwhelmed and dang, Thomas is holding me up for Bitcoins. Let's talk later, Thomas. But if you guys feel a little overwhelmed, don't worry. This is actually, you have to reinforce this, use your own examples, look at other examples online. So don't feel stressed out that we have too much, there's so much here. This is just examples of how you use the Python node and how you edit your content. So you're more familiar with the system. Okay, let's do one more thing. We'll take a break. And so I'll unhide everything, reset. And if you guys ever screw up this model, you have no idea what's going on. Hey, you got the Dynamo pack, so just keep downloading them and get the original model. Let's do, oh yeah, let's go back to the presentation real quick. All right, let's go to, take the circle out because that was a note for me, don't worry about that. So let's say like, great, I don't want to write this out every time. How do I do this myself? Simple as, I actually put the link in here. You can, from the primer. If you ever want to see a good example of documentation on tools, the primer is a really great example because it has a whole section on custom nodes, Python nodes, the whole deal. At the end of the Python nodes section, it has a whole Python. So if you ever want to review, I actually got a lot of notes from this in my place myself. It has a lot of great examples. But right now we're looking at the template. If you ever want to add this to your own template, and don't feel like you have to do it right this minute, but if you want to follow along, you just go to your folder that has this. So it's usually, it'll point to it. Sometimes it's Dynamo Core, sometimes Revit. I'll just kind of take it there myself. Hopefully I can navigate towards it. It's going to be, is it app data? Let's go to, because part of this is want to do a template. So let's go to this PC, my PC computer. Is it going to be my username? Don't tell anybody my secret stuff. Yes, go to my username, go to app data, go to roaming, go to Dynamo. I don't have Dynamo Core because I think this example is from either Dynamo Studio that is showing us here from Primer or Dynamo Sandbox. Dynamo Revit should be just fine. Then go to the version. I'm using 2.3. That's the annoying thing about Dynamo. There's multiple versions. Each one needs this adjustment. So let's say I'm doing 2.3. What you want to do is go to this XML file. It spells it out all right here. I'll tell you exactly what to do. You go to the XML file. Well, before you do that, you want to create a Python template. You can literally just edit a text file. Open with, screw it, I'll just do it right now. Just for fun, text document, I can call it Python template 1. Change the extension real quick. You need that py for Python file to exist. If you want to change it, now it's a Python file. And you could just, you don't even have to use a text editor, just go to Notepad. Notepad technically is a text editor. Is it a good text editor? No, but you can modify your code in here. So it's always an option. Then what you want to do, I'm going to copy You can probably, let's see how well this works actually. I'll probably copy from my PowerPoint right here, import, see if this is like jacked up or not. And then I can copy in here the boilerplate. So it means every time I open Python node, instead of that default stuff you guys are seeing, you can use this boilerplate. And you can change this to whatever you want it to be if you don't like what's here. I think I literally copied this from the primer because I'm like, oh, they probably know what they're doing if it's from the Dynamo team. Save it, come back here, go to Dynamo, escape, right click on this, open with Notepad as well. Open with Notepad, scroll down to, I did add it here, didn't I? Let's look what the primer says. Scroll down to a string. Oh, there. Might be a little hard to read. That's fine. Just scroll down. I'm just going to follow its instructions. To app data. There it is. So we're going to add this to the. Oh, thank you for adding the Git book to the class. I highly recommend. We'll talk about that later. That's a good one. Somebody added it to the Slack. When you go to Python template file path, which is what we're looking for here. Okay, so Python template file path. Let's stretch this out a little better. And if you screw up, don't worry. I just recommend making a copy of the original Dynamo settings first, so you can always adjust this later. Maybe I didn't put this in here. That's fine. Python template file path, C users 2.3 file path. I'm just going to do whatever it tells me to do. Control C. Make sure I got the right one though. And I just control put it in there. And put 1, 2.3, make sure you get that correct. Oh, so app data, users. So let's use my actual path. You can probably just copy it from here. It's probably going to be easier. String. So make sure you put the correct path, 2.3, Python template 1, that's string, Python template path, should be like that. There you go. Save this as first real quick. Copy, paste. Always a good idea to copy up your original in case anything gets screwy. File save. And then ideally, when I go back to Dynamo, close actually Python and open up a brand new script, and hopefully it doesn't slow down too much. Lottie-dottie. No, you don't like that? Okay. Python. Let's a minute here. Well, then it should give you the new template right there. So you can actually just add whatever template you want in there. So if you didn't get it right this time, don't worry. The notes are in the primer. It's in the deck. You can always add it. So you can then not worry about adding all this stuff or finding out what you need to add. This is a good starting point. You can delete things if you really don't think you need to have system in it, just delete it, because you can always like save that, make another Python script, and then it'll just have all that default stuff in there. So it'll always come back to that. So that's a good way to organize your content so you always have the same stuff. I just went with the primers notes. So let's take a break. And just a shout out here to Thomas for bringing this up. This is a really good resource here. He put it in the Slack channel. He also put the cheat sheet in there. So check out what Thomas has been adding, because the cheat sheet is pretty useful for like all these values. We talked about lists and everything. There's a lot of Python. The essentials anybody can learn pretty quick, so don't feel intimidated. This is a good example for that, so kudos. And this is Python. We're not sure which version of Python it is, but I don't think it matters, so don't worry about that. There's 2x and 3x.
It's both, yeah.
Okay, so this is baseline, so it's fine. Oh yeah, Python, thank you. Python 3 and 2, there we go, yeah. For those of you who are curious, they made some changes from 2 to 3. The basic stuff like this is pretty much the same. The difference is Python 3 lets you use all those cool data science packages and everything else, Django, Flask, 1,000 other packages. Python's real strength isn't so much it's a simple language. It is a good thing to have. It has a ton of packages, third-party or open source community support, meaning corporations don't make it, like users make it and distribute them. And they're like the best tools to do a lot of manipulation of data. You can make websites, you can do 1,000 things with Python because people create these packages. Dynamo would be like kind of an example of that. It's not a Python package per se, but it interacts with it. So there's a lot there. Python 2 is old in this case. People are trying to move away from it. Python 3 is a new version, which is, if you want to use all this new stuff, the latest version of all those community packages, you want to use Python 3. Dynamo up till now has been Python 2.7. And the team finally got into what they call CPython. Right now it's IronPython. IronPython is what they use to communicate Python in Dynamo to .NET, Revit. That's the best they could do because they need an implementation. So for the abstraction, but CPython, which is very similar, it talks to .NET. So multiple variations exist by different contributors. There's IronPython and CPython. Dynamo team is now trying to support CPython, and that's going to let you use all the data science packages. So CPython has Python 3. So all the latest things can now be compatible with Dynamo. We'll talk about that at the end. But this is all the same good baseline stuff. And when it comes to the skip book here, I've seen it too. I would say to reinforce the stuff and actually go a little bit further beyond this little document we got here in Slack here, very good stuff. It tells you somebody else created a skip book. Always read the documentation. Documentation usually looks like this. And it tells you very similar things to what we talked about today. So I highly recommend looking at this and, save this, do a nice little save bookmark, save this somewhere because this is a very useful document. You'd be surprised how much documentation is out there, but this is one of the better ones. Okay, I'm gonna get some, do I have coffee? I have coffee. Do I have water? So I should be, okay. Yeah, there's a whole world out there for learning this stuff. And
But I had a question. You said that it's going to support CPython. Like, when would that take place?
now, but you have to install yourself Dynamo 2.8. I'll do it. I haven't gone there myself. I have Dynamo 2.6 of Revit 2021. So 21 comes with 2.6 built in, which is nice. They're always trying to progressively update the Dynamo with every Revit release. 2.7, I think, might have been the first one. So you can actually go to the website. Show this real quick. I think it's right here. Dynamo builds. Hopefully this is the right one. Yeah, and you can then find these. So you probably want 2.8. So follow the instructions on the wiki. Don't do it willy-nilly. It should work just fine. But I think there's a special way you install 2.8. So they're still kind of like testing it out. All Dynamo versions. But you can actually literally put in 2.8, which comes with CPython, which can then let you use imports. Like we did import for Dynamo nodes and all that. You can do an import for NumPy, import all sorts of stuff. Just
yeah, so
Python.
you could import. Where would the imports come from? Like, if I had a Python environment, like, how would I direct it to those imports, or does that have to be located in a certain place?
You have to do. You have to install it first, so it's not installed. So of course, all of you have to install Python. You didn't have to install it for Dynamo, But if you want to use Python outside of Dynamo, because Dynamo builds it all into you, so it's all taken care of, you'd have to, let's see, can I do it from here? CMD, I'm not going to do it live now, but pip install and maybe like NumPy. Look this up, but basically in a nutshell, that's how it would work. You'd have to do either command line through the command prompt like this one from Windows, or your text editor, like VS Code can do it too. You have to have some kind of command line terminal interface and pip install the package. Then you can import the package. Yeah.
Yeah, I'm just saying, like, I have a bunch of packages installed, but they're in a virtual environment, which is located in a different folder than like Python 3 interpreter. So I'm just wondering, how will Dynamo know? Is there like a pointer that takes them to all the packages that are, you know, pip installed onto your computer? Like, do they have to be pip installed into a specific directory?
So maybe I can answer that question. So Sol Amor has an article about that regarding how to get NumPy working on it. You have to get Anaconda open in the background, and then you can have your NumPy inside of Dynamo, which is kind of ghetto, but well, Autodesk.
Okay. So it goes through Anaconda. Okay, got it.
See, if you have that running in the background, and then you write, so you're creating a link between your Anaconda and Dynamo. Or actually, it kind of does it for you in a weird manner.
Yeah.
It's still kind of going through the, you know, it's like a beta thing they have at this point, but yeah, there's ways to use it. So I posted a link 2.8, and if you just look up 2.8, you'll find, like Thomas said, more information on it. It's not like fully featured yet, so yeah, they are still trying to become better at it, or make it a little more smooth. Because fun fact, Dynamo team itself, they released the sandbox Dynamo. Revit team, which is a separate group who develops Revit, then has to take Dynamo and put it into Revit. So it's a bit of a handoff in Autodesk itself when it comes to doing all this stuff. So it takes time to smoothen all this stuff out. It's not one group or another. They actually have to, here you go, put into Revit, put into Civil 3D, put into Alias. They're trying to make it for everybody.
So you can use your Anaconda virtual environment to install your packages and run that just through the Dynamo Python, right?
Probably. Let's put it that way. Yeah, I haven't tested it myself, but I've seen examples of it that way. Yeah.
Okay, cool.
Okay, let's continue. I'm going to speak through the rest, a lot of these until we get to an example. Because we got 15 minutes, so I do want to have time to get questions. So there'll be one example that I'm going to change that real quick. Don't worry about that. There's one example I do want us to kind of play with, so I'm going to save time for the end. The rest of this I'll just talk through. Don't worry about like you're going to miss anything. It's more like concepts. So exercise 5. If you want, you can open the files and look at them yourself. I'm not going to edit them live. I want to keep going here. Our functions. Functions is another way to work in Dynamo, and you can do it just through this code block you see here. I believe that's the exercise 5.1 example. If you want to open up and look at it yourself. What's cool about functions is this is all design script, by the way. There's nothing to do with Dynamo. Design script, it's like a little language that looks kind of like C# for Dynamo to put in there. You can use C# itself with zero-touch nodes. You can use design script, which kind of looks like C#, but it's not really C#, into the design script language. You can also use Python language in Dynamo. It's pretty flexible. And with the design script, what you can do is you can have a code block up here. Pretend it's your Dynamo environment. You can have a code block just floating around, touching nothing, and create a definition function name, not connected to anything, and then come back, create a code block, and create function name back here. And it'll actually, even though it's not touching anything, there's no strings connecting to it, it'll run in the background, and you can use the functions to then do some operations like add 2 numbers, 2 plus 2, integer 1, integer 2, like that. So if you guys, design script's pretty cool to learn on its own, because you can further compress text and nodes. So if you use that in conjunction with Python, you can actually make your scripts very packed, so it's easy to manage. And you can do basically parallel the design script function language into Python. So they're pretty much similar, these two. You can see here the input's the same. The difference is instead of using the code block, I'm using the Python script. And then it's the same thing, sphere by input. And we have the same idea of radius divided by 10. This is just some formula. And the sphere node, remember this is a sphere node, sphere dot by point set of radius. You can literally just make this as a Dynamo. Dynamo has this already. So we're just writing it in. Remember, we can write it on nodes as long as we import the library. And then we can put the input, the point, put the radius, return the sphere. So as you can tell, they're very similar but different. In the design script language, you have to create the code box after the point is then to finish it out. Whereas in Python, you could just put it into, to get it to run, you have to have the points as the next step after the script runs. In Dynamo, in Python, though, in Dynamo, it's basically built in. So, and here's the return equals sphere. There's no return equals anything, which is return sphere. So the function's basically def function, both of these. So you have to type function, to make your function work, type def. Then the name you decide to give it. I think you can just invent the name just like anything else. And then in the brackets, you have a value, then you put your function, then you have a return statement, and then you can put it either ahead of the, like in this case, you put it ahead of the inputs. Sorry if I'm going too fast, I'm trying to catch up with everybody. There's many opportunities to use functions of both. This is something you want to read up in. I think the Git book that was posted on Slack has some examples of this. Again, this could be a whole class on its own. Functions are a pretty cool feature that you can make operations within your code. So they're very similar to one another, whether it's design script, zero touch, or Python. And you can actually prototype tools a little easier. In this example, you can prototype a color changer tool where you have the Python script taking in the pattern, the colors in RGB, and the elements you want to change the color. And I'll just talk you through this, which is we have all the import statements to modify. We have that doc equals document manager because if it's an existing element, we want to modify the existing element's appearance. We do have to use that whole transaction schema. And after we put the doc equals all that, we then put the function statements. We want to convert the color, return a result, and then we want to create another function to override the element information, return, and we just tell it what we want to override. Then we put up the inputs. In this case, the function goes ahead of the inputs. And then we have the iteration loop. And you can see here, that's the transaction. Transaction start, transaction ends. So I don't expect you guys to get this all at once, but this is an example. Don't feel like you have to, understand this immediately. The example is you can combine the functions, the transactions, the loops, the inputs, all that to create your own tools. This is something you want to look at yourself. And what you're seeing here is basically using elements of Python coding with functions, elements of the Dynamo script, and elements of API to the Revit API to modify your content. So you can do this. You can just select elements and change the color on the fly. And you can then do something like this where you just create sliders for the RGB values, drop down pattern, and change the colors around and the patterns around. So this is a prototyping of a tool. So if you're like, oh, this could be really useful, I had something like this, then you can either use it as is, as say, I believe this could be done as a player script. Don't quote me on that, but you can actually set all these inputs to be a player script, and then the Python script will take care of the rest. And you can modify your elements on the fly with these inputs, so you can change colors and patterns very quickly. So I show this example to give you a sense of how functions can be utilized to modify code, but also to give a sense that you actually prototype some real tools that can be used for the next step, or if it could be used for your editing. So if you're interested in that kind of thing, there's a whole world of functions out there. You have to get used to the language they use here, but don't feel overwhelmed. It's just, at the end of the day, it's research. If you have an idea, this is how you get to that idea, is research it. And I give credit to this one for Danny Bentley. He has a whole series on YouTube about how to do this kind of work. So I'll leave a link for all this stuff at the end. And we're going to do try and accept next. Again, I'm going to talk through this because if you want, you could open up exercise 6.1 just to follow along. And the idea of try except is if you you want to do something and until you hit a exception, and then you make an exception, and then you move on. So you don't end up in these loops. Every loop I've shown you so far has worked out just fine because I made it that way. Sometimes it doesn't. Sometimes you have to tell it like your data is not so clean, and you have to tell the code what happens when we get to a thing where the iteration has no idea what to do with it. Well, you can put a try except. So it's like try, run this code, except when there's an exception, it doesn't meet the requirements, I say it. And you can also put an else statement. We're not going to get into that, but there's if else, try except. Try except is pretty good when you're trying to when you have a problem, you're trying to make the list iteration continue, basically. And then it'll keep going through it, all these statements, till finally it's done running the code. So sometimes you get a list or some kind of input. Then this is a good way to make sure you don't break the code. Sometimes your list, it comes from some source from Revit that's junk. And some of the index values, the element values, might be not very good. And it's going to hit a barrier and you're going to have a bad time. So try, except, if else are good ways to overcome that. It says when you run into these problems, do this. And here's an example of that. I can just talk through this. This code here is going to take the points and do something with it. So it's all just generic Dynamo in this case, so we don't have to have any other statements. It's going to be points value in, right? Pretty simple. And then that's 0. I'm going to have a series of x and y coordinates. 0, z is 0 because x, y just defaults to 0 in this case. 0 through 4, 1 foot in increments, so I have 5 values. Pretty straightforward. X and y. And it says, okay, for every PT in points, give me an appended value of what y equals. Okay. It's not going to be this one. This one is actually the clean version. This one just spits out with whatever z is. So this could be output z, and z is all zeros. Okay, so this is actually clean. So the top one here is clean. The bottom one here is the exception. So when it's clean, great. I just said give me z. We did that. When we want the exception, where in this case I nullified 2. I just took out the index item there. I just took it out. If it says, okay, for every time in points, look at the y value, point.y. Okay, except if there's no value, give me a message, add y value, and then put that on list. So see how it's null? So every time so this is Python scripts, I'm telling it, I want only the y values from this coordinates, because maybe I want to modify the y values. I want to do something with them. But should you have a null statement like this, give me a return so I know that something's up here, so that I can then understand what to do next. 0, 1, oh, well, index 2 here has no value. Please add a value, 3, 4. That's a good cue, or I'll tell it skip it, rebuild the list and skip it. So this is a way to basically clean up your, get past some problems, because otherwise it might break, it might crash. This is a learning curve. There are many examples with this. They just end up being much longer examples than what I have here. So I give you a very, very simple example where people are using either try, except, or if else. And they do this in order to avoid running into a wall and crashing the file, or it gives you a warning or error saying, I can't do this, I can't finish. This gives you a way out, try, except. And this is just documentation. So I'm going to get to this example right now, but this is more documentation. If you go to this Dynamo GitHub, I'll just put this into the Slack so you guys can see it. I just have to put it aside for now.
If the
Dynamo.
Python component fails, will it crash Dynamo, or will it throw an exception?
It should just throw an exception. It should be the error handler. It usually doesn't. Sometimes it'll crash. Sometimes, but most of the time, the Python script. Now, the Dynamo script might crash, which will crash Revit. But the Python node itself usually just gives you an error. So if you do find things crashing, it could be the rest of the script, potentially. So usually when I run into problems, it's not that bad. I just have to figure out how to get out of the Python error, which could be a lot of research, but it shouldn't. The Python on its own usually doesn't crash because it's going to compile the script, it's going to run the script, check if it even works, and then do something. So that's good to know. It's Python generally, like I think in any implementation of Python, it'll run the script to find out if it works, then it'll do something. If it ends up saying, hey, like line 34 makes no sense, I'm not even going to do this operation, that should usually save you from crashing. So, and that's generally speaking how Python, my experience with Python, where in any way I use it, it usually works just fine. Or if it has an error, it'll just tell you. So it was like, hey, I checked it first. It doesn't work. Please fix it before we actually try to get you any results. In a nutshell. See, it's worth talking about. I'll just talk through this example as well.
I have a question. Are you gonna show us like how to debug? Like, does it show you the line number and where does it show that, or is that something we're gonna go through?
Yeah.
All right, cool.
I'll give a debug example. It won't be this, but this one just gives you more of an idea. This guy used try except. So what he's doing here is he's putting the code blocks to give him walls. It's going to give you this. It'll just spit out walls. And what he's doing here is like saying, here's the points to, here's the width of the walls, here's the height of the walls, here's the leveling up the walls on, because the walls are level constraint. And he gives you all 4 points of a four-cornered room. And it's pretty easy to read, but you can see the try except. That's his way of making sure the boundary lines aren't going to go out of bounds. So that says, if you have an index error, do this. So that's one example of making sure like your process works, because it should just work with this code, but it turns out we need to add try except in order to make this work better. So that's an example to make sure we don't have any errors. Otherwise, the wall will not finish being made, or the 4 corners won't be finished. So if you ever see try except or if else statements in these codes, that's because they're trying to make sure that if you have bad values, index errors like this one, that you can then accommodate that. So that's how you get out of that situation. Skip these graphs. I'm also going to talk through graphs real quick. So everything I've done up to this point, most of them have been pretty much just revolving around the Python node, as though it's the only node in there, or with a few other accessory nodes. The reality is, most of the time, you're going to have a Python node on top of a bigger script. So just get used to working with them. The key is to make sure the entire node graph is easy to follow and define. And depending on how you create it, everything can be containing Python. That's ideal. Or you need to have multiple nodes doing different things, and you have a kind of a bit of a mixed bag. This is exercise 7. You have to use this family type loaded into the model. Use it. All this is showing you a slider that can create something like this wall, or excuse me, this curtain wall, and that can expand upon it. I can make it bigger or smaller with these sliders. But see how we have design script, Python script, Dynamo nodes. This is probably closer to a normal script using code, text code. So the key thing is, there's nothing wrong with it. Ideally, the more compact, the better. The key thing is to make it clear what you're doing with all this. For example, the code block here for number 8 is spacing. Tell me how far spacing is apart for those curtain wall panels. So when it gets kind of weird like this, where we have all these notes, and oh, by the way, we have this as a cross product. If that wasn't clear. Very sneaky, right? Triple X cross product. So just do your best when you get these things to just spell it out. And in the Python node, add the notes. The inputs up to this node will be stored as a list in variables. All right. not hard to understand. And then place your code below this line. But you can also put in things like, why I have nodes +1, why I do the iteration here, why I have vertical times j is the iteration. So without context, it's harder for me to manipulate it. But cool, it does something. What if I wanted to modify it a little bit? So add notes throughout the script. And I think I still have Dynamo open. Control W, add notes with Control W. You can also, by the way, probably float off to the main screen like mine. You can also just do edit, create note, and you can just type in, by the way, you explain things to people like that. You can also make it easier, group things. I'll just do it the old-fashioned way, create group and, group description. The spelling is right. Just clean it up is what I'm trying to say. Clean it up, put notes. So this is more of exercise, and like when you have these kind of varieties of different things happening, clean it up. Doc is not, and by the way, when it came to the error handling, is probably a quick example. What happened here was doc is not defined, right? So let's see if I can run it again. That's fine, I'll delete this. That's because we hashed it out, so I'm gonna undo this. Cancel. So if I hashed it out, right? You saw me do this last time. Save changes, run. What's it telling me? Doc is not defined. So when it throws you an error, sometimes it's actually pretty easy. It says warning, Iron Python, evaluate your script. It failed. Most recent call last. It actually, in that sense, goes to the most recent thing. If it's so it'll go to the last thing it does. If you think line 1 here is the least recent thing, line 23 is the most recent thing. So it's actually going to figure out what the last problem was. And let's see here, what's it say? Line 13, doc is not defined. I'm like, oh, why is that? It says 13, but it's actually 12 because it went right after 13. It went through 12, hit 13. It's like, wait a minute, what's doc? I don't even know what that means. That's what Python is trying to tell you. All right, because I actually hashed it out. It has no idea what doc means. So it's telling you, I looked back and the most recent thing on the list, number 13, I need to do doc first. I don't have that. So you save changes, run it again, and it says, it gives me a new one. The most recent thing is iteration on line 17, trace back, iteration over non-sequence of type, non-type. Now, if you didn't know any better, you think that could be any jargon. All that means is you have nothing selected. See, that's a good cue. It's saying doc.delete iteration, right? Element, well, there's no elements. So there's a lot of jargon in here, but you can actually probably just, literally copy paste this into, copy paste this into Google. Google's your friend. And you can at least kind of research what the hell this means. And it might take you some time, but you can find out. So it's jargon, but you can be like, wait, I have nothing selected. It wants me, clearly I need to select something. It could be that it detects this wrong. Could be you have no colon there. Could be you didn't delete it. Could be a lot of little things. Try to do your best to figure out what the jargon means. You'll run into this all the time for many different reasons. Again, in this case, we have nothing selected. So in this case over here, elements not defined, line 35. That just means we have nothing. This is blank. There's no code in here, so nothing's defined. So you just have to get used to reading the debug. All right, I'm gonna speed things up. Maybe have to skip something here. Oh, good, we're at problem solving. This is perfect. Okay, let's, we're right where we want to be. I'm gonna have to speed up towards the end here. Don't worry though, this is a good one. So problem solving, great seg, because a lot of what we want to do in Dynamo is or Python coding, any coding whatsoever, you have to problem solve. All those set piece examples I gave you were based on me making sure they work. A lot of the times, if I gave you something just out of the box here, I think this code will work for you. You get it off of GitHub, you get it off of Stack Overflow. It's hit or miss. So how do you then figure it out? So one great resource we have here is Revit API docs. I'll just type it out here. It's an open source project that gives you the entire Revit API. The Revit API is a beast. It has something like 30, 35,000 entries for everything under the sun, built about 20 years of experience from the coders. So I'll put that on the Slack channel too. And that's a great reference. You're probably, if you're going to do a lot of this stuff in the API docs, or API in Revit in any form whatsoever, whether it's the software development kit with C#, Python, Dynamo, this is going to be a resource to find things. Again, this is a whole 3-day workshop on its own. We're not going to really do much besides skim the surface, but you're going to probably use this resource a lot. I think some of you already have. And this is where you want to start. Look, remember those examples I showed you earlier where we're interacting with some Revit elements? This is where you go to find what those elements are called. So an example here, we're going to play around with that. So we're going to number 8 at this point. I'm going to close out Dynamo at this point. I don't trust anymore. I'm clearing out the memory just in case. So sometimes you run into errors. You're like, huh, I thought I fixed that. Close Dynamo. Just close Dynamo in case sometimes the memory is just, I don't know how to describe it, but it just kind of like stays in the cache. It sticks around. And your errors just stay errors for no good reason besides you have to refresh Dynamo. Let's go open number 8. And good. And we're going to freeze the second one. And all we're doing, all we're doing here is we're going to highlight something. So we're going to do the drop down to the wall. Select your handy dandy walls. It'll just create a list. That's all this does. It's give me a list from the wall. And the Python code here is going to give me type mark. So great. This will then give me a selection. It'll tell me the type mark of all the walls. So we have our import statements helping us out there. A transaction. Then I got the built-in parameter, all, underscore model, underscore type, underscore mark. That comes from the Revit API. You have to look that up. It's telling me, look up the built-in parameter for the type mark. Provider is what the parameter value provider is. That means element. Look at this element. The element ID is this one you want in the built-in parameter. The evaluator is the filter string equals anything. That's empty, so anything goes. The rule is correctly. The provider and evaluator has A6 or it's false. And then a filter for the rule, and the walls then collect the filtered element collected from the doc. All this does is gives me a list, so that's all it does. So if I run this, I get a list of, it gives me every wall in the project as a category, but the code actually gives me the ones with A6. What does that mean? Let's go back to the Revit. This wall here, I think all the walls here should be the same. The value is, in a type probably, type mark A6. So the built-in parameter gave me A6. But what if I want something a little different? For example, if I come here, I actually want all the walls that have, I want to use a different value. I already have A6 built in there. So yeah. What if I want to use, instead of the type mark, I want something else because I want to get a defined value? What if I want something in the comments? So right now I have, let's go to the main course. I want only the walls to show up, the review. it's great to have A6. I just want review. So how can I then take my code here that only gives me the type mark, and I want review. I want the exact same thing. I just wanted to do review. So here's where having fun with the API comes into play. I already know, going back to my Revit here, that what I'm looking for is comments, right? Under the type mark. So I already have comments. So let's do that first. Let's reverse engineer this. Let's go to the Revit API. And you can all, I put it in the Slack channel so we can all come here. And we're gonna go type mark, or I should say, take that back first. I want built-in parameter. So just type it in, it'll give you some search. This looks like a good start because I want to see what's in the built-in parameter. Built-in parameter, what's all the parameters in the wall? Let's go there, click on it. And we have a bunch of values. Look at that. This is all the parameters you could put into your values in Revit. That sure is a lot of parameters. So what we want to do is Control F, go to, I already know type mark works. So if I look for type mark, what would I find? It gives you 3 options. It's going to be sheet assembly type mark. That's not it. Window type ID. It's a wall, so I know that's not it. And then all model type mark, which, hey, isn't that what we had here? All model type mark. Pretty sweet. So I'm like, okay, I'm on the right thing here. Great. I know that's where it came from. So I'm in the right place for doing this, finding it. So what if I want comments? Remember, comments is what I want. I don't want type mark anymore. Well, I'm gonna have some fun and see if comment works. So I got sheet assembly. I got load comments. So I'm just looking through, probably none of these because they have nothing to do with my model. I got instance comments here. That's a little best. All, the entire thing. Remember last time was all, let's go back here. All model type mark, all model instance, because this is instance based. You have to remember if it's type based, which is, you know, you have to edit the type, or instance where I can just write it out. I'm thinking it's instance. So this is one way. So I'm like, okay, can I take what I have here, copy it? Because again, this is the actual, you know, built-in parameter. Go back to my code. And you guys, if you're feeling confident right now, you can follow along. Come back to the code, change that. Oh, did I copy it? Change that. There we go. So give me the built-in parameter. Again, you come back to the Revit code. It's all built-in parameter, right? It's enumerate means giving you a list. Can I just change that out? Save changes, run. The C, it didn't, oh, it run started. So hopefully I don't crash here, but sometimes it might not take the chill pill well. So I just switched it out real quick. Let's see if I, in fact, close the, yeah. So it started, I don't think it stopped. What did I do wrong? It didn't return anything yet, so fingers crossed that this is good. Well, I put in all model instance comments, but if you look at the string here, I didn't tell the comment. So I have A6, that's the type mark. It's not gonna understand what, there's no instance comments with A6, that's the type mark, so we have to switch it out to review. That's what I want, because back here in the Revit model, I want to find everything with review in it. Let's save changes. I might have to reboot Dynamo real quick. Oh, maybe it's because I have this open. Minimize. All right, can you, hooray. I don't think it took that well, so I'm gonna do it one more time. So actually, let me put A6 back in, because I have the parameters options on this. Let me just do it one more time. Run. Empty list. That's not an error. It just says I have nothing for you. The error handling is like, oh, line 30, whatever, fix it. In this case, it's like, I don't know, there's nothing in here. Nothing matches your statements. So we go to review. It's like, you know what? A6 is not what I wanted. I want to review. Save changes, change the string, run that. Then I get my list. So you can actually modify some basic research on the API. And you can then highlight, which is convenient here, is you can just click on the element ID and highlight it in Revit. Being a little stubborn, but you get the idea. Or you could just do, you know, element.geometry. And everything's being a little slow today because, of course, it would. But that's how you use the API to help you do something. You know, let's maybe not do the geometry. It's being finicky today. That's how you use the API to help you find information. That was an easy example. There's thousands of entries. Basically, all the stuff in Revit, massing, analysis, steel, it's in here. If it's built with the Revit, not as a third-party tool like, you know, my Imaginer tools, but like out-of-the-box Revit, it will be in the Revit API. There is a lot of stuff in here. This is a learning curve. You just have to kind of find out which one, modify and modify it. Oh, you want the API. So if somebody wants to copy and put it in the Slack as well. So,
Thanks.
sorry about that. I was all over. There it is. Actually, it's on here. So thanks, Jack, for the documents as well. So here's the built-in parameters for the enumeration if you can't find it yourself. Not hard to use a tool, but it is a learning curve. Revit API is a beast. If you guys are familiar with, say, Rhino API, not so bad, Rhino API. A lot of APIs are not that bad. Revit API is a beast. It is kind of complicated, hard to navigate at times, so that website can help you. And always feel, and I'll talk about how you can get more information as we go about how to solve problems. We're in the home stretch here. So I'm gonna
We
continue.
should write a letter to Autodesk.
We should
to
definitely write a
improve.
letter to Autodesk. Yeah. By the way, shout out to Guy Calorico here. This guy, this is an open source project. Autodesk, you can get this documentation from like the install file of Revit. Guy took it upon himself, this guy, to actually upload this onto a website so people can actually search for it. Autodesk should have done this. Every modern company does this except Autodesk for Revit. I don't know why. That's their thing. He did an open source solution of writing this onto website. There's every version from 2016, 2020, 21 will come along. And it even has code samples in Python and C# if you guys want to peruse through that. That gives you different ideas of how to work with it, get all work sets. It'll show you all that. And this can be useful for Dynamo, Python, PyRevit, all sorts of versions of Python. It's not just exclusive to any one of them. So shout out to Guy here, because Autodesk for some reason doesn't do that. They should, they don't. So knowledge-based
Tadeh,
coding.
I had a question. What if we're trying to run a Python script that is written inside of Dynamo in a PyRevit shell? Would that work? Because it's kind of taking in on the same documentation, right?
I've not tried that myself, but what you would be able to use PyRevit to launch a Dynamo script. But now are you trying to say transfer it over? Like, you know, I'm going to take the Python logic. Yeah.
Yep.
Most of it will transfer over. You do have to modify it. So if your logic is correct in Python Dynamo, PyRevit has a ton of resources online to show you how you can then take the Python logic into PyRevit. It's more, the workflow for that is usually C# Python, without even talking about Dynamo and all its quirks with the output node and all that stuff. But if the logic makes sense and the inputs, so you have no inputs, that's a key thing. You have to do what they call filtered element collectors. We saw an example of that earlier with the some of the API scripts. You have to get used to filtered element collectors. So instead of using Dynamo to collect things for you and select things for you, you have to then build it into your code.
Oh.
And then the other iterations. So the logic is, you might have to rewrite the entire code, but if you know the logic works, like, okay, this will work in Dynamo with Python, it should work in PyRevit. But you may have to either redevelop it or just restart over, but you're on the right idea at that point. But realize the Python node in Dynamo has help from the input nodes. And but you can literally make a Python node in Dynamo. It's just Python, pure Python, and run it. If you can do it that way, you can then take that logic, put it into a PyRevit script. So, but if you have input nodes helping you along, and in Dynamo, you then have to figure out how to make that work without the input nodes. That's the big step.
Understood. Thank you, Tadeh.
Sure. So real quick, we're gonna get into, can't get into everything else real quick, but I'm gonna skip a few parts and talk fast on some others. Oh, come on. Switch. No, you're not doing that, huh? I'm just trying to show you the, oh, you know, it doesn't matter. So knowledge base for coding, 20% Dynamo, 20% Python, 10% Revit API, the other 50% is from researching things on Google. There's no way you're gonna know this all in here. Just learn how to copy paste the right kind of error handling questions onto Google. Learn how to ask questions on forums. Learn how to find your solutions, because the vast majority of things, it's good to be savvy in coding. If you know Dynamo well, this helps you a lot. If you know Python well, that's gonna help you a lot. If you know enough of the Revit API to at least understand where to go, there's no way you're gonna memorize it. It's thousands upon thousands of entries. You're just gonna know enough to know where to go and look for answers. But the vast majority of this is looking things for online. So don't feel like there's like 3 answers to error handling and debugging. There's a ton of different possibilities. There's 100 ways. All those examples I showed you earlier, there's 100 ways they could be rewritten to do basically the same thing. So always find ways to answer these questions and do your best to document. You know, between the Revit API docs, the book for Dynamo Python, those are documentations. Do your own part when it comes to making notes and comments in your script to help you and other people follow along, so that if you ever have to come back to it or, you know, explain your own logic without to relearn your own scripts, it'll be easier. So always document. Real quick, we talk debug. Sometimes you have no idea why your Python script doesn't work, and you get these error boxes here, and there's just no, you know, sometimes it's really cryptic. I would love to give you guys a whole list of things here about debugging. Again, that's another class. But in a nutshell, here's my debug tips that can help you. Usually it takes more time than you realize. It might take you like 10 times the amount of time to debug and figure out why your script doesn't work, and just create the script. You know, Python, like we saw earlier, will tell you which line 30, 13, whatever. That's the most recent one. That it doesn't start from like top to bottom saying the first thing here doesn't make any sense. It's like the last thing in the sequence, the latest thing in the sequence doesn't make sense. Fix that first. And then you can tell, it'll give you either something pretty straightforward, like, I don't know what doc means. What does doc mean? I don't know what doc means. Please explain this to me. Or it'll tell you like, iteration of enumerator value was not iterated. So you have to get used to learning that jargon. Your syntax makes a big difference. A lot of your error handling is like you didn't put a colon in there, you didn't use brackets, parentheses, indents. That's every coder. You just have to get used to the syntax. That happens to be all the time. I'm typing so fast, I forget to put a colon in there or something. So make sure you're reading it correctly. Punctuation, capital and lowercase makes a difference. So make sure you're using the right, there's protected classes of text in there that will change color, right? I think we can see this in here, that if it's colorful, yellow in this case means, it depends on which text editor. This is a basic text editor. If it's colored, that means it's special. It's a string. It's a like from import, that means something. You can't use these just for fun. You have to use some other name, like import to. But don't even use the word import if you can help it. And then other things here, it's hard to see here, but this is highlighted bold. Built-in element collector. That's an operation. That's a function. A built-in function. So pay attention to how you write that stuff out. Otherwise, it won't work. Import modules, right? So if you don't import the modules, it won't work, and sometimes you may not know. That's why I'm saying just kind of import everything and just figure it out from there. If these aren't imported, but you need to use the Revit services or the Dynamo services, the Revit nodes, this won't work. I was like, I don't know what you're talking about. I can't import the module. I can't do any of this. So until you import that, it's not going to work. Use the correct operators. So in the right place. So that, and if you can't, like multiply, divide, whatever, make sure you use the right ones, otherwise it doesn't work. Or you have to use PEMDAS, parentheses, exclamation, was it? Yeah, parentheses, exclamation, multiply, divide, add, subtract. That could give you problems if you're trying to add, concat strings, add strings, do some manipulation. And sometimes the Revit API changes. Autodesk likes to have fun with us and change the API every so often for some basic stuff that shouldn't need to change, but they change it for whatever reason. So that's something you wrote in 2019 for Revit in 2019, you bring it into Revit 2020, it doesn't work because you have to look up the API value for those enumerated docs and all that stuff, the built-in parameter. You have to find, maybe they changed it, maybe they use a different like class. Go figure it out. That's a problem. This happens to every developer, third-party developer on Revit. They complain about it too, where it's like, you know what, it would work just fine, but the API call changed. We have to then look for that, like it was all model type doc, whatever. Remember how we switched that out for the code to get the ASICs to look for review? That might change, something else changes. Sometimes your code isn't bad, it's just the API changed. You have to find the updated API value, which is always fun. I'm not sure how much time we have for that. I'll skip the next section as far as doing it, but real quick, I was hoping to dive into VS Code. Unfortunately, we didn't have time, but what I want to point out here is an actual live example. What I want to point out here is VS Code or any text editor. There's text editors, there's full IDEs. You can literally copy paste your code. Let's see if we can just do this real quick. Control C. Go back to VS Code. Helps if you have a Python. So I'm just gonna read all this and not save it. And as long as it's a .py file, it can. As long as you have Python pre-installed, your text editor is up to date, and you're using a .py file. If it's just untitled like this, it's not gonna understand it's Python. It's text. It's like everything's white. That's how you know you're not using a .py. So make sure you save as the .py. And then the benefit of using a text editor is just faster, especially if you have longer code. Come on, let's minimize. Go back here. There we go. And then what we saw here, where it was like, as I was typing, as we're all typing, it was able to do things like color it up, right? But what's good with text editor is it helps you shortcuts. Like if I have to do Revit services like here, so you have to like, if it was the Dynamo editor, the built-in one, I have to do the whole thing manually. I could, with text editor, it actually gives you the quotations. I do the first quotation, then it finishes off the second quotation. It helps you basically. It helps you work faster. It'll figure out, hey, like if I put parentheses, it'll give me the rest of the parentheses. I don't have to do both parentheses. It's a beautiful thing. So whenever possible, use your text editor to help you out. If it's a long thing and you're like, you know what, I can't read this. And if it's a simple statement, you can also do a check to see if like you're missing something. It might tell you like, oh yeah, like check out this thing. Like you have the wrong value. Either you should use a colon or a semicolon. It'll help you out depending on your text editor. So, and it's a little easier to read in my opinion. And you can change all the colors here too. So don't be afraid to use a text editor outside of Dynamo, because that Dynamo, this one's not bad, but it's, again, if I have to literally type out the parentheses. It slows you down a little bit. It's kind of hard to read this stuff. So I'd rather just, if I'm doing a lot of work and I'm not paying as much attention as I want, use a text editor. I also put a link in there for Replete. It's an online text editor. In case you don't have your VS Code somewhere, there's an online version of this. The Python, you have to make sure it's running Python, and you can do the same thing. .py file, run Python. Again, this is probably a good future class, is to just use text editors with this code. So if you're not already using a text editor like VS Code, just free, most of them are free or have a free version, go get one. And just appreciate how it works, because that's a big one. Distributing your scripts, real quick, you always want to code, test it, make sure it works, then deploy it. Especially if it's like they rely on you. Like I'm talking about more than one person here. In my company, I'm responsible for vetting and distributing all Dynamo scripts, so I really want to make sure I test it first, so I don't give people junk and then they come back to me asking why line 37 has a, you can't iterate over a non-whatever iteration. I don't want to deal with that, so always make sure you test, then deploy. One way you could do it is built-in, is to just use the package. You can create your own packages and nodes in Dynamo. I wrote down the steps here. It's also in the primer. Pretty simple. You literally just, I can show you real quick. you literally just select all the nodes you think are valuable, right click. Actually, I should probably do this one. Right click, create custom node. So you have to right click outside, don't touch the nodes, outside, create custom node. And give it a name, 123, 123. Okay. Custom node error. Items category. What does it say? Okay, that's fine. Oh, I have too many. One sec. New, how's that? You like that? Great. Now I can double click on this, and there it is. You can. That's one way of deploying it. This could be a whole class on its own. I think, yeah, there it is. It's new. So I have to get rid of this later, but don't crash. So that's a DYF file, is a custom node file. If you want to have fun, go to the data shapes. I think just about any one of these data shape packages are good fun exploring things. If you go to export any of these reading, double click on it. He has the data shapes itself, everything's in Python script for the most part. And you can actually double click on it and look at what it says. So if you're ever curious how some of these work, you can just open them up yourself. Double click, open them, and you can read the Python script. Some of them do C#, some of them don't let you edit it, but this is a fun way to discover how people make their own solutions. And there's lots of examples in here to do something like, export to FBX. That's a file type export. You can read in their own codes how this works. They also have GitHub and all that stuff. Sometimes they have node links to their sites in here as external packages. I highly recommend you guys want to learn more. Try to find these packages that let you just look at their stuff. Sometimes it's C#, sometimes you can't see it, but they usually have a GitHub to give a little more detail. Okay, we're gonna sprint here a little bit, guys. You can also use GitHub. The great thing about, so the limitation of Dynamo Graph is it's either this custom Dynamo file, which is you have to open a Dynamo, or it's a picture. So it's limited in sharing it, but if you use Python text, you can literally just add it to GitHub as text and share it that way. There's also a DynaHub package for Python. Dynamo, which lets you open up the packages, either Python code or Dynamo scripts. I believe I have it installed here. Oh, I don't have it in this version. I have it in another version, but you can install it, link it to your account on GitHub, and open your scripts that way. Real good. I highly recommend you guys try this to put your repos on GitHub. And I highly recommend also just Control-C, Control-V. If your code's online like that, I encourage every one of you to share your code, share what you've learned, show examples, let other people kind of pick your code apart and use it yourself. It's better for the whole world to see what you're doing than to keep it to one person. So that's how I learned. That's how I got a lot of good examples. I share everything I do. So put your stuff online, share the code. Because if it's online, you can literally copy the code from GitHub or another repo and paste it into Python that fast. You don't have to download stuff, you just copy paste. That's the beauty of text coding. Follow up. We went over the essentials of how to use Python Dynamo, its peculiarities, how to create a template, how to use the IDE, how to debug. Again, those are all lessons on their own, but at least you know the beginning points of it. And I'll skip this. Just real quick, the future here is now you can kind of do whatever you want. You can do a ton of things with Python Dynamo. You can do analysis. You can use the refinery toolkit to do generative design and give you more options there. Python is great for integration. You can integrate a lot of services with Python, not just Dynamo, but Excel. Put them together. You can do energy studies with it. Python has a lot of possibilities with just Dynamo, and this is what CPython looks like. You can actually do the settings drop down with 2.8 and change it to CPython, which is Python 3. They make IronPython 2 and CPython 3. The entire time we've been using IronPython 2, so that's the future. They released this. It's still early, but it's the right direction to go. I have some additional alerting here for all these great things, and you guys can follow up with it. Some things from the primer, the forums, university, LinkedIn Learning. You can get free trials of it. YouTube has a lot of great stuff, and Python stuff. Once you feel comfortable with Python, I would highly recommend just keep using it. You can use PyRevit to create your own custom add-ins. You can use it to create scripts in Excel. Python's pretty compatible with just about every kind of major software tool. You can use it to do data science with pandas. You can create websites with Django. You can use Raspberry Pi and program for that. You could do machine learning. Python has a ton of options, so I highly recommend just keep learning Python. You won't be disappointed. More additional learning here, so that you can learn from these examples. Stack Overflow is a great resource. GitHub's a great resource. Learn Python is as well. Ask the internet for help. And here's some teams to follow that have a lot of good examples of code they've worked on. And I'm 1 minute overdue, but here's my contacts. If you want to contact me, if I didn't get to something in the class today, or like you want to know more, you can either put it in Slack or just contact me directly. If I can't, I'll do my best to get back to you guys. I'm gonna give you this whole deck as part of that Amazon link that you got earlier today, and you can see all that stuff in there. And yeah, 3 hours flew by pretty quick. I hope you guys got something out of it. I think we have a 30-minute break. I'll hang around for a few minutes if you guys want to talk, and then yeah, it's a pleasure for you all guys come here and feel like we had a good session today. I opened it up to comments and discussions if you have anything to say.
Yeah, just real quick. That was awesome. I definitely learned a ton from that. I'm a Grasshopper developer for the most part, so it's cool to see so much being available within Dynamo. I actually started in Dynamo as a developer, and then I moved over to Grasshopper, so I think I might have to jump on back after seeing this presentation. Really, really cool. Appreciate you taking the time to meet with us all and you know, go through a large variety of topics within Dynamo. I think one question that I have is importing DLLs in from external kind of libraries within Dynamo. Is that possible within the custom components, or do you have to install it somewhere before using them? And then to get farther into the weeds, does it have to be a 64-bit DLL because it's Autodesk? Yeah, I'll just kind of leave it there.
That is a great question. Because up till now, it was kind of futile to do anything besides the IM Python version of it, which is kind of like packaged with Dynamo and Revit. The whole DLL business. In a nutshell, yes, because you can use it. That's how a lot of these third-party packages. I think it was, which one was it? Let's see. Rhythm, I believe, does this. So there's ways you can import it. Off the top of my head, I don't have the exact method, but yes, you should be able to do that. It would be something like, let me see here. Just going through, I just want to see if I can find it real quick. I'll just bring it up here real quick. I'm taking a wild guess if it's in program or is it users, Hakopian, that's not deep enough, app data, roaming, Dynamo or something else, Revit. Okay, it's definitions, nope, logs, nope, if you go to whatever rhythm. So as you can see, they have their own DLLs, and they kind of just come packaged with the service. So based on that, I let's say there is a way. I don't have the method off the top of my head, but the packages do it. So I'm pretty sure you could do it with Python in the import. Since I either use the packages myself or just whatever came out, Revit nodes and Dynamo nodes, I have not experimented, but I'm pretty sure the answer is yes in this case, for at least the IM Python version we've been using so far. Yeah.
Okay, thanks.
Yeah. So I just question everybody here, did you feel like there was anything missing from this presentation or we didn't go over enough in this presentation that would have been helpful? I know it feels like it was drinking out of a hose. I want to make sure we had the fundamentals down as much as possible. It's like how you edit the nodes, what kind of things you do in nodes, and then the more advanced topics. You can always review those because they just show you examples of what's possible. So did anybody have any comments or opinions about that? I'll take that as I did a great job and everybody got the quality education they want out of it. But
Yeah, I can say some words. For me, it was very good. So I also kind of prepare at the moment a Python presentation, just a short intro, not a complete class, but I think overall it's quite good. But sometimes I think it would be good to show the solution first, what is the goal, and then go into the Python part and try to work like you did it already. So sometimes that was missing, I think. But overall, it was perfect.
Thank you.
Yeah, it's so hard to take on something like Dynamo and teach it in, I mean, even 2 or 3 hours. It's like,
Oh yeah,
there's so much you can go over. And I mean, I didn't even know about some of the debugging stuff, and the function stuff was new to me, but I've been using Dynamo for 2 years, so there's just so much stuff you can cover. So I think you did a really good job.
And 6 o'clock in the morning.
Yeah.
the sun is out in LA now, so yeah, it's 9 a.m. around here. So yeah, it's easier to focus in the morning, in my opinion. So I was actually feeling pretty jazzed about it. And that said, there's like 700 Dynamo nodes, 700 more Revit specific nodes to even look at if you just want to do out of the box generic, visual scripting. So Dynamo on its own is a pretty deep program. Python on its own is a pretty extensive language. So to me, this is always the long, it's a marathon. This whole thing is like just learn as much as possible, but don't be in a rush. That's why I told everybody just take the examples in, see what's possible, and then go about it yourself. This is the difference between learning a coding language of any kind and learning software. In 3 hours, I could have shown you a lot of how to use Dynamo, for example. In 3 hours, I could have shown you a lot of how to use Revit. In 3 hours, we're only scratching the surface of Python. That's the big difference, because there's so much more into it. The concepts are different. You have to think through the problems. Everybody has a unique problem. So I think you guys are all on the right track. It's only been a couple of years since I've been going down this road myself, and I'm always learning something new. Experienced developers. I talked to Ehsan, who's the developer of PyRevit. He told me he's been doing this for a long time, coding. He's always learning something new. He's been coding for 10 plus years, however long. He's pretty experienced. He works at McNeil, working on Rhino Insight right now. And he's always telling me there's always something new. The best advice he ever gave me was document and comment your content. That's why I keep telling you guys to document and comment. Share your information so other people can learn your examples, and hopefully other people can show you some solutions to your problems down the road that they share too. And always go back to your old code and try to improve it, because that might be a lesson. You're like, oh, why did I do it that way? And then you can find ways to improve it, because that's the long journey here through the coding. Is to pay attention to what you're doing. It's almost like you're learning a martial art or something like that. You're never going to learn right the first time. You always have to improve upon your techniques.